request all our chief gatherings to assemble in the stage, and by inaugurating the session through lighting of the lamp, I kindly request Dr. Shalini Rajneesh, Chief Secretary of Governance of Karnataka, Mr. Shri Pankaj Kumar Pandey, Principal Secretary to Government Department of Personal and Administrative Reforms, Shri Shashank Mishra, Joint Secretary, Ministry of Power, Mr. Abhishek Agarwal, Scientist, IndiaAI Mission, and Professor Rajesh Sundaresan, Conveyor, Deans of Division, IISc, to join us. I kindly request all the dignitaries to light the lamp and officially inaugurate the session. Na deepo bhasate sthane, na gnane na vinamanaha. That also talks about the resilience always comes with, as a lamp shines only placed steadily, the mind illuminates only through knowledge. So thank you all dignitaries for officially inaugurating the session. Now I kindly request Dr. Rajesh Sundaresan sir to felicitate Dr. Shalini Rajneesh, Chief Secretary of Government of Karnataka. Just a small token. Sorry. Yeah. Thank you, ma'am, for joining us. I again request sir to felicitate Shri Pankaj Kumar Pandey, Principal Secretary to Government, Department of Personal and Administrative Reforms. I request sir again to felicitate Shri Shashank Mishra, Joint Secretary, Ministry of Power. And I request sir to felicitate Mr. Abhishek Agarwal, Scientist, IndiaAI Mission. Yeah. And I request Professor Vinod Ganpati sir to felicitate Rajesh sir. Yeah. So as the process taking place without much delay, we know all of us have connected the dots for this from scale to resilience and rethinking efficient AI systems. So let's kickstart this whole official discussions by starting with the welcome address by Professor Rajesh Sundaresan, Conveyor, Deans of Divisions, IISc Bangalore.
Thank you. A warm welcome to all of you on behalf of the Indian Institute of Science. I'm Rajesh Sundaresan. I'm the current Dean of the Division of EECS and also the convener of the Deans of Divisions at IISc. A special welcome to all our guests on the days. The Chief Guest, Dr. Shalini Rajneesh, Chief Secretary, Government of Karnataka, Mr. Pankaj Kumar Pandey, Mr. Shashank Mishra, and Mr. Abhishek Agarwal. Let me also welcome all the members of the working group on resilience, innovation, and efficiency. the officers of the Ministry of Electronics and Information Technology, and also the officers of the IndiaAI Mission. Today's meeting is to facilitate discussions on moving artificial intelligence systems, or AI systems, from the current resource-intensive path to a more robust and resilient and energy-efficient one. So the meeting is aptly named From Scale to Resilience, Rethinking the Efficient AI System. It aims to reimagine a world where AI performs across diverse contexts and thrives despite limited resources. The event is organized by the Ministry of Electronics and Information Technology, the Government of Karnataka, and the Indian Institute of Science, with support from IISc's Foundation for Science, Innovation and Development, IISc's Translational AI for Networked Universal Healthcare, IISc's Art Park, and also the faculty, staff, and students of IISc. At the Indian Institute of Science, I'll say a few words about the activities that we have undertaken at IISc in the AI domain, particularly in this resilient AI domain. We have been keenly aware of the need for efficiency in AI systems and also capacity building in this domain. Just as application-specific integrated chips enable much higher efficiencies than general-purpose processors, for example, application-specific AI could provide the pathways for resource-efficient AI systems and AI scaling. The Indian Institute of Science has enabled the pursuit of such application-specific AI in networking at IISc's Center for Networked Intelligence, in robotics and autonomous systems at the Art Park, in a critical infrastructure at the Power Grid Center of Excellence in Cybersecurity, in cybersecurity itself, at SciSec, this is the Government of Karnataka supported KTech COE in cybersecurity, in health data at the ICMR IISc Center for Health Data, and in translational AI for Networked Universal Healthcare at TANU. I must also mention here our efforts to learn efficiency by studying perhaps the most natural of intelligent systems, the brain, and applying the learnings to AI systems. And this is being done at the Initiative for Brain Computation and Data Science. These initiatives build as part of their mission application-specific artificial intelligence for efficiency as well as robustness. In an effort to unite all of these core activities at the Indian Institute of Science, all these initiatives at IISc, we have also enabled the Kotak IISc AI/ML Center for capacity building. This is at the undergraduate level through support for the BTech Math and Computing program, which started in 2022. The graduate level MTech in Artificial Intelligence, something that the Indian Institute of Science pioneered in 2019, and also a new PhD program in AI as well as AI plus X, where the plus X is a way of indicating the growing influence of AI in a variety of fields, in probably almost every field. I hope that over the course of the day, there will be opportunities for all of you to learn about the initiatives that we have started here, thanks to support in a large part from the Government of Karnataka, as well as from the Government of India and from philanthropists, and find ways to partner and contribute to their strengthening here and also to their impact to the greater society. Once again, let me welcome you all to this meeting, and I wish you all a very fruitful discussion. May I now, do I mic? Okay, all right, yeah. So thank you very much. Welcome once again to the Indian Institute of Science.
Thank you very much, Professor. It's always said IISc is where questions are sharper than answers, and we know why it is said so. Thank you, sir. Himself being a research allocate who has been working a lot on decision theory, network system, decentralized algorithm, and the list goes on, sir. I have a bunch of lines. Thanks for being part of this and welcoming everyone. Again, welcome you all for this. Welcome you from the departments for this amazing event. So now, without much ado, I would go to the next part of the event, where governance today is no longer just an administration. The governance itself is a system thinking at the national scale. And now today we are so honored to have our chief guest, Dr. Shalini Rajneesh. I have a small bio, ma'am. We'll read and leave it to you. And the moment we hear about Shalini, ma'am, she is like one of the dominant personality of the education system in the Karnataka economy. So when we go through the system. She is a distinguished administrator and reform-driven leader, currently serving as the Chief Secretary of the Government of Karnataka since 2024 August. A 1989 batch IAS officer and the batch topper, she brings together academic excellence and transformative governance. Renowned for spreading the Sakala Mission, Karnataka's flagship time-bound public service delivery program, she has set a national benchmarks in technology-enabled governance, earning prestigious recognition such as National E-Governance Award and the Google Innovation Award. As Chief Secretary, she continues to drive digital transformation, institutional reforms, and strategic economic initiatives, including planning of Invest Karnataka 2025. This is what Google AI told, ma'am. But on top of that, the moment we hear her name, it's because of a couple of books. I literally marked down those books' name. The first book is Nimma Bhavishya Nimma Kayali, IAS Akankshigalige Margadarshanaಗಳು. To be honest, as a Kannada reader, ನಮಗೆ ನಿಜವಾಗ್ಲೂ ಅಂತ ಪುಸ್ತಕ ಸಿಕ್ಕಿಲ್ಲ ಮ್ಯಾಮ್ ಇಲ್ಲಿವರೆಗೂ. Thanks for authoring those books. And she has been one of the pioneer women in engineering leader who is a rare blend of administration and technology together. Thanks for doing all those things for society, ma'am. So I request you to address the gathering.
ಎಲ್ಲರಿಗೆ ನಮಸ್ಕಾರ. A very good morning to all of you. It is indeed a very timely intervention on the part of our e-governance department, Indian Institute of Science and Government of India for the upcoming AI Impact Summit in Delhi to hold this kind of a preliminary or a warming up session in Bangalore. Bangalore, which is the heart of IT and AI. I would not talk about what we have already, but I would talk about what I wish we have. And I'm sure with AI in place and with all of you collaborating as a team, this is possible and this will be shortly made available to public at large. We have this e-governance department, as you know, which is a pivot of all the departments and their electronic database as well as softwares in governance. However, till today, we have not been able to integrate all the data sets and the databases and the softwares of different departments. Isn't it, Pankaj? It's a big challenge. But the intention is there. Then how do we first ensure that all the data systems come together? We had started this project with the help of IIITB to create a data lake for data mining and then lead to AI applications. Now, to a large extent, a data lake is ready. Most of the systems are speaking to each other. However, there are interoperable issues which we have to sort out without further delay. Otherwise, we are not going to use the potential that we have for using AI, because ultimately, AI is based on what you feed. What is the legacy data? What is the information that is available over the years? And then it comes out with an intelligence output. So I would request my department secretary, Mr. Pankaj Pandey, and his team to work together with IIITB and the Indian Institute of Science and other IT agencies, particularly with a lot of R&D and the GCC centers which we are lucky to have. Can we bring together all this data in an interoperable fashion? And then start using it for applications for the citizens first. Of course, taking care of the privacy and other citizen concerns. The numbers are what are important. I will just give you one example from Agriculture Department, for example. When we created this data lake, the query that I put into the system was that I have this major crops, say 5 major crops of the state. Out of them, which part of my state is showing less than average yield? And you will be surprised to know we were ourselves surprised to know that out of 6,000 odd gram panchayats that we have, the problem was only in 300 odd gram panchayats in terms of productivity. And when you dig deeper into layers and layers of information that you are having available in terms of particularly the soil type and the micronutrients, you find that a very small component of, say, zinc is to be added. In milligrams, it has to be added, which can increase the productivity many-fold. Now, this is the huge potential that we are waiting for on one side. And on the other side, in terms of resource allocation, why am I distributing fertilizers and all kinds of inputs to all crops in all regions when it's not required? It is automatically being taken care of for whatever actual situation that it has. The second example, I would say that we have websites for all departments. It is all standardized by e-governance department. But my websites don't speak to the citizen. I have collated almost 1,000 schemes of the government from all departments with a standard template wherein it talks about what is the scheme name, what is the eligibility criteria, how do I get it, and what do I get? So maybe these 3-4 queries. Now, I have to fill up. In the website, if I operate, yes, I can fill up my details that I am a farmer or I am a fisherman or woman, and this is what I want, and the system will generate. But can we have audio operated, AI generated intelligence and services given to the citizens for their various queries, depending upon what they want to know from the government or from the public domain as such? Similarly, we have these health records. I think Dr. Devi Shetty would be coming around. Many of the conferences that I attend, even the last one was on cancer, you see the entire data of how the diseases behave, how the patients go through, and if that all that is digitized in a meaningful way, you know what predictive analysis you can do. Today, we are actually at loss to understand that without tobacco or usual causes of cancer, for example, majority of them have none of these factors as the causative factors. Then what is it that is leading to cancer? What is it that is leading to high rate of cardiac arrests? Some say it is because of the vaccine we gave during the COVID time, but we don't know. So unless we put the whole data together and the scientists and the researchers work on it and do the predictive analysis, the preventive part of it, the curative part of it can be very, very focused. Just as I mentioned about the agriculture productivity, the same is true of human productivity. Am I able to improve upon the human capacities? So governance issues, public system issues are myriad, but answer is one. I have to put them together. I have to put them in a way that they are organized and they are able to be culled out based on the need of every individual, which is citizen oriented. Finally, I would like to say that today AI infrastructure is the need of the hour, and I look at 3,000 of my engineering colleges to become the hubs for the entire state of Karnataka. The graduates, the engineering graduates, the IT graduates, they should be creating their own labs and incubation centers in every academic institution, and then that leads to a multiplier growth, because we also need lot of skilling. Today, I'm sorry to say, I have been hunting for people to work on my AI project. But it's very, even triple ITB says I'm not able to supply data scientists, data analysts, AI analysts to you. So what kind of changes do we need in the curriculum today at different levels, not just at the higher education level, but even at the higher secondary level? How do we bring in more and more of capacity building, more and more of uh, orientation of the IT based skills that are going to be required in the days to come. Now we don't have months or years; we have days to come. We have to be very quick in our in every pace of development that we do, and it is not possible by anyone single-handedly. It's always possible through a collaborative effort, and I'm so glad that we have the best of brains, best of minds here, and if we don't do it, no one else will do it. So I implore through this platform to each one of you, please come forward with your strengths, with your skills, with your intents to serve the country, serve the people of this our motherland. At the same time, shine in the global horizons, as we should be seen as the best and delivering the best. Thank you very much.
Thank you, ma'am, for reminding us that AI's true success is measured by in the public trust, not just performance. But one line which strikes us very strongly is if India has to drive, it has to be led by Indians, and it's a co-verse, right? India has to lead, and Indians have to drive it. So that echo lines of what we can do in future is just it's not something which is there in next 5 years. It is in next 5 days. That's the speed and pace we have to take it forward. Thanks a lot, ma'am, for that energizing address. Now I request Shri Pankaj Kumar Pandey to deliver keynote speech. Before that, just a brief intro of Pankaj sir. So Shri Pankaj Kumar Pandey is a seasoned administrator of the Karnataka Cadre 2000 batch, currently serving as Principal Secretary to Government DPRA e-governance, a key driver of digital and citizen-centric governance. He plays a pivotal role in strengthening technology-enabled public service delivery in the state. Sri Pandey sir also brings rich cross-sectional experience from leading KPTCL as managing director to steering critical departments such as health and family welfare during the COVID-19 pandemic, tourism and commerce, and industries, an IIT Roorkee alumnus and All India Rank 1 holder in the Indian engineering services. He exemplifies the fusion of technical excellence and administrative leadership. I now invite Shri sir to address the gathering.
A very good morning to all the dignitaries sitting on the dais, my esteemed colleague and a guide to all of us, Dr. Shalini Rajneesh ma'am, Chief Secretary to the Government of Karnataka. My colleague in the power sector, Shashank, we have been working together since last so many years on the power sector. Professor Rajesh, the custodian of this entire conference and for organizing, Abhishek Agarwal from IT. All the industry leaders, researchers, innovators who have come to this warm-up session of the conference on AI. It's a very good day to start that, because I think 15th February is the time when we go for the main conference. Now, I like to personally welcome you, obviously, to the city of Bangalore. Many people have come from outside. And this is a city which has reinvented itself from many times, from being a public sector hub to IT/BT services, from a startup to deep tech. And we have never given up adopting technology. We have, in fact, shaped technologies over years, the city. And right now, when we talk in various conferences, they say, or many times in our power sector also, they say that the AI machine learning is the flavor of the season. I will say it is no longer the flavor, it is the main ingredient. Like the ubiquitous Indian curry, it is present everywhere. So it is now no longer the flavor, it is the main course. And therefore, we have to take it up immediately. It no longer designs code. It is no longer the predictive model that it predicts something. It now designs, codes, diagnoses, plans, and most importantly, it is now deciding various things. And therefore, it's a choice. It's no longer a choice. It's a necessity. But now the main question is, how do we operationalize AI at a very large scale? And that is where we as a country need to look at the advantages that we enjoy right now, or at an advantage at which we stand right now. We are at a rare intersection of four things. We have a scale. 1/6 of the humanity lives in India. We have talented engineers, scientists, domain experts in India. We have a democratic complexity in terms of languages, culture, geography. So you have all kinds of complexities in the country. And then we have an urgent need in the sectors of health, in the sectors of energy, agriculture, governance, everywhere. And therefore, when we stand at such an intersection, I think we should not miss the opportunity of using the AI at a good scale. In fact, in Karnataka, as Madam was mentioning, we have been using AI, and we, around 2 years back, came out with a dedicated AI cell. The cell is based on 4 pillars of advisory, giving the advisory to the various departments, solution development, upskilling, and collaboration. And we have done a lot of in-house initiatives. Just to tell you a few, we have developed a Kartavya, which is the AI-powered attendance for all the government employees. Around 0.13 million employees, or 1.3 lakh employees use that. Then we have done something called muzzle print. In fact, we are doing it with the help of Indian Institute of Sciences only, where we will be basically generating an ID for the cattle in the state. Around 10 million cattle are there in the state, and we will be developing that. Then we have a AI-powered students attendance system. In fact, with the education department, we are going to use it for around 5 million students in the coming days. Then we have a Saramsh, which is auto-generation of and auto-extraction and summarization of the various government orders. Suppose if I want a government order on particular subject, I can auto-generate and then auto-summarize the government orders. And this is under pilot stage. Various things are under development, or they have been developed and they are being piloted. So these are the various things which we are doing in AI. In fact, Karnataka was the first state which has gone to the India AI mission, and we have taken up the GPUs. We have taken around 92 GPUs from the India AI mission. Now, these are the few things which we are using, but at the intersection of various departments, as Madam was mentioning, this data transfer is the most critical thing. And one of the test cases or use cases which Madam told is about helping the farmer or helping the agriculture or horticulture. I come from a department which is not liked by the finance department, the power department, because almost 20,000 crore of subsidy is taken by this department. Major portion of this subsidy goes to the farmers' irrigation pump sets, IP sets. We have an astounding 35 lakh or 3.5 million irrigation pump sets in the state. And almost 40% of our energy goes to the irrigation pump sets, for which the government provides approximately 20,000 crores annually, and this bill goes up. Now, one of the ways of using AI at a scale is obviously to find out the weather, the cropping pattern, which particular area in the state or which particular village has which crop, and therefore what is the water requirement, because every crop has a different kind of a water requirement, and some of them are perennial, some of them are seasonal, and depending on that only you push the power in those feeders. Otherwise, agriculture feeders, which are primarily meant for the irrigation pump set, should be switched off during that point of time because they don't require the power. That way you will be saving power, you will be saving water, and obviously you will be saving the soil also. Otherwise, many areas they do the flood irrigation, which basically removes the top layer of the soil. Now, this is a test case which will help everyone, the farmers, the power department, the state government, and all of us. We are working on that. this, if integrated with the horticulture agriculture department, can provide good amount of information. So proactively pushing, using the AI and pushing the information to the final user is what we want, and we have been trying to do in the department. There are multitude of possibilities in the department. I remember when I joined my college in Roorkee University, it used to be called Roorkee University or UOR, University of Roorkee, in '94. The computers were rising. Obviously, they were reaching a stage, and we had in the first year a necessary course on computer sciences and electronics. The first year course is common for everyone. Now, what I feel is AI should be mandatory, and it should be mandatory not only in the colleges but in the schools as well, because that is where we will be developing our talent. We will be developing the kind of skills that we require for our students and for the future generation. In fact, going forward, what I feel, this is my personal feeling, that the way we have corporate social responsibility, we should have a corporate R&D responsibility on every company. We have been seeing the R&D spending which happens, and unfortunately, from the industry, we don't get that kind of R&D spending which should happen while the government or the public sector or the institutes do a lot of R&D and spending. Now, I think the time has come where we should invest a lot on the R&D, on the human HR skills, and obviously recalibrate our curriculum in a way that it is AI oriented, because this is something which we can't skip. With these thoughts in mind, I would like to thank everyone, to the organizers and to everyone for giving an opportunity to me to speak from this forum, and best wishes for this conference. Thank you very much.
Thank you, sir. It reminds us, Sri Basavanna tells this beautiful vachana. It goes like, Yenna kale kamba dehave regula shirave honna kalasvaya. So he goes like, if only rich people can go and build some temples, what else I can do? Then he says, you yourself is a person, your whole body is a devalaya. Just tweak it to the AI world. People should not always blame, I don't have RAM, how can I build something? No, you have a system to do something. Now, when you listen to the talk he has gave, he beautifully narrated how the systems and architectures or the India's role pivots is not just with some pivotal institutions doing it. It's all of us coming together, even with a small component of readiness. If a country which can build a system with 5 billion records, a country with 131 billion people can providing one single input instruction set, we can build a better ML than anybody in this whole globe. So that's the kind of scale and that's the kind of scalability we're thinking about. Now I would just summarize that one line. It's like 1.4 billion citizens, one digital interface, and that's the scale we are looking at. So it's both Shalini ma'am and sir's talk. So thanks a lot, sir, for that amazing keynote. So we are now going to the summit address. We have Shri Shashank Mishra, sir, who is IIS of 2007 batch officer from Madhya Pradesh cadre, currently serving as Joint Secretary in the Ministry of Power, Government of India. He plays a key role in shaping India's power distribution reforms, working closely with states and DISCOMs on smart distribution, RDSS implementation, and the adoption of AI/ML technologies in the power sector. An IIT Delhi electrical engineering graduate, Sri Mishra sir brings strong technical and administrative depth to the sector. He also serves as government nominee director at the boards of REC Limited and Power Finance Corporation, and has previously held impactful leadership roles across central and state governance, including director in the Ministry of Finance and senior positions in infrastructure, smart city initiatives in Madhya Pradesh. Again, this is Google AI generated, but the moment you look into his profile and the biodata, the kind of actions he has taken, one thing is for sure. For a long time, the most disputed part of India was about power energy. I don't want to go to the details of it. Everybody knows. But that was a sector where we all talk about AI and everything. We never think about, do we have so much energy in the systems? The power and energy is such a point or pinnacle point of the force, we always keep on forgetting. It's like, ide irutte nodkona bidi. It's like sometimes back we used to tell in villages like, karante barala, ratri bidkonte neerna anta. It was always in a discussion, right? Technology was not overtaking power, but we're so happy today. We're at a position where we are talking about implementing, low power energy strategies for driving the better AI reforms. And that's happening across, and we have a representative to talk about that. I invite you now for the address.
Thanks. Chief guest of the event, Dr. Shalini Rajesh ma'am, Chief Secretary, Government of Karnataka. My senior colleague in the sector, Shri Pankaj Pandey sir, Principal Secretary to Government of Karnataka. Professor Rajesh Sundaresan from IISc Bangalore. Abhishek Agrawal from AIT. Excellencies from participating countries. The developers, the contributors to the sector. Good morning to you all. It gives me a great pleasure to welcome you all to this stakeholder consultation that we are having on the India AI Summit side event. And this is a hybrid meeting that we are having on the pillar that is being chaired by Ministry of Power, the meeting on the Resilience, Innovation, Efficiency Working Group. We deeply appreciate the inputs that we have received over the past few days of, in fact, past few months of engagement that we have had with all the stakeholders in the working group. Also the stakeholders that are contributing to the development of how do we exactly want the AI to lead in the coming years. Your participation definitely reflects our shared conviction that the next breakthrough in AI won't be just about the larger models or the expansion of the compute power. Today we are talking about edge computing. Today we are talking about small language models. What can be pruned, how the efficiency can be brought into the AI sector. Since our first meeting, we have been greatly encouraged by the quality of inputs we have received. Your contributions have kind of inked at both the urgency and the opportunity before us to design the AI systems that are efficient, adaptable, and accessible, even in the low resource settings. To start with, all the AI models, they came with high monthly subscriptions, which were required to be paid by the users of the AI. Today, that is going down, and that needs to further go down if that needs to be more and more made accessible. As the AI systems scale up, the nations face rising pressures related to energy use. Today, in the start of the event, ma'am was talking about we have a lot of data centers which are coming up across, including in the Bangalore around area, in Andhra Pradesh, in Gujarat. What are we going to plan? How are we going to plan for this energy requirement, energy demand? And a lot of in fact, a lot of effort has gone into planning the resource adequacy plan for the states. Also, a lot of efforts has also gone in developing the open access systems, the captive power plant. The new rules, new regulations have come in to support the entire system. At the same time, there is a significant opportunity to design the AI systems that maximize societal benefits, and this would require minimizing the resource intensity through efficient models, adaptive architectures, and responsible deployment frameworks. As I mentioned, we have a working group which is working on the concept of innovation, resilience, and efficiency. AI must be resilient enough to function reliably across the context, and efficient enough to be accessible to all. Today's meeting brings different perspectives, in fact, diversity of perspectives. Your insights will help shape practical, globally relevant outcomes and ensure that our work reflects the world constraints and priorities. Also, as was mentioned by my earlier speakers, that there are a lot of fragmented digital systems which are there in different sectors, including in the energy sector. I would take this opportunity to mention that India currently is also working on the concept of India Energy Stack. So as we have the UPI model for the financial system, similarly, we are developing the UPI model for the energy systems. And going forward, these energy, which we call as Unified Energy Interface, that would be interacting with the UPI system, and that would make the energy as a new currency. So P2P platform is peer-to-peer trading platform is one thing which we are working on as one of the use cases under the India Energy Stack. And we are hopeful that in the India AI Summit, we'll be able to launch that as one of the platforms which would be a role model for the global community at large. And there are other five or six use cases that we are working on, which would really shape up the future in the distribution sector and in the power sector, in fact. The rollout of the smart meters has been one thing which has been really supporting this cause because of the real-time availability of the data. At this instance, I would like to thank India Institute of Science and Government of Karnataka for their efforts in convening this meeting. And I thank you all for participation and commitment to this important agenda. Thank you.
Thank you, sir. So it also reminds us some ancient thoughts like Shankaracharya's once he said in the Bhajagovindam line, it's like it goes Punarapi Janam, Punarapi Maranam, Punarapi Jani Jatare Shayanam, Iha Samsare Bahudussare, Kripaya Pahe Pahi Murare. If you look into the philosophical context, there's a different meaning. But if you look into the concept of these systems, it comes down like we have failed multiple times. Let it be, we will openly agree we will fail. But we are the only country who takes failing as a fast measure and coming out of it and bouncing back in a quicker manner. And today's power sector is all about getting back to the systems where, when he was talking about UPI model, me coming from a finance sector, I have never seen such a model across the globe. We bank the world banks, the companies where I come from, but they openly tell this is something that India has proven the world can be transformed like this if digital presence is available. So, and we are happy, sir. We are looking forward to see it in the power grid. And thanks a lot for this amazing, address at the gathering to set the context on how energy and efficiency is going to take forward in the AI era. So now we come to the most important part of this whole summit to understand what is India AI impact all about. And we are looking at AI impact summit as a keyword everywhere in these systems. So we have today to present a national perspective on India's AI vision and impact pathways, Shri Abhishek Agarwal. Abhishek Agarwal, sir, is a senior scientist and policy leader serving as scientist in the AI and Emerging Technologies Group at METI, Government of India. A key contributor to the IndiaAI Mission, he plays a pivotal role in shaping India's AI governance and policy framework. He was part of the high-level committee that crafted by India AI governance, defining core principles for ethical, safe, and inclusive AI, representing India in global firms, including India-France AI Policy Roundtable in Paris, and leading national stakeholders consultations with UNESCO and METI. He is at forefront of India's aligning AI ambitions with the global best practices. I request Shri Abhishek sir to address the gathering.
Yeah, namaskara. Thank you. Mr. Pankaj Kumar Pandey, sir, Principal Secretary, Government of Karnataka. Shashank, sir, Joint Secretary, Ministry of Power. Professor Rajesh from IISc Bangalore. Other respected professors from IISc Bangalore, and my friends from Ministry and from IISc Bangalore. A very warm welcome, a very good morning, and I really I would like to thank IISc Bangalore and the Government of Karnataka to organize, to host this hybrid meeting of resilience, innovation, and efficiency meeting of the working group meeting. So my work here is to go through the details of the Impact Summit, from the Government of India point of view, what we are looking, what we are trying to do with this India AI Impact Summit. And So the journey of this summits started from November 2023. It started from the Bletchley Park, where at that time, Honorable Prime Minister of the UK, Mr. Rishi Sunak, has started this AI Safety Summit, which was held in the Bletchley Park. It was a big gathering of very big leaders from the governments and the industry. And the main focus of that summit was about the safety, how to make AI safe for the citizens of the world. So after that, the Korea took the lead and organized or hosted the AI Seoul Summit in May 2024. And the objective of the summit was the innovation. So and then the next was done by the France in last February 2025 in Paris. That was AI Action Summit. And if you see the journey from the Bletchley Park to the Action Summit, it started from the safety, then it moves toward innovation in the AI Seoul Summit, where it talks about the innovation, coordination, cooperation. And then in the in the Paris Summit, France and the other countries talked about action, what to do so that we can leverage this AI, the technology which we are looking for. And in the current, after that, our Honorable Prime Minister, Shri Narendra Kumar Modi ji, in Action Summit, where India co-chaired, he announced that now we have taken the we will take the baton and host the next summit in this series. This is the fourth summit. And now our vision then further transferred from the action to the impact. Since we have talked about the safety, innovation, and the action, now the time is to show what is the impact of AI in real life. So, and if we see the scale, it started from the participation of 27 countries to the 100 countries over the time. And also in our summit, we are looking for more than participation from more than 100 countries and from the industry leaders. Next slide, please. So this the Impact Summit, which we are hosting, so it's not a 5-day event. It's a process which started from the last 4 to 5 months. It started from July, August. So there are various parts to this process towards the summit. We are hosting pre-summit events starting from the August itself. We are also organizing the working group meetings virtually and the hybrid. Today is the one of the hybrid working group meeting in IISc Bangalore. And this objective of these meetings is to shape the summit outcomes over the various themes, various domains of the AI. And we are also in the process of hosting the regional convenings to encourage the Jan Bhagidari in this process, so that to become more inclusive and to take everyone along. And also in the summit, we are having the flagship events, such as there will be an Impact Expo, and there are innovation challenges which are also launched during September, October this year, in which we are looking for the startups who are making impact. There are 3 challenges. One is general, in which every startup can participate. One is specifically for the women, and the one is for the yuva, like the students. So and during the summit week, that is from 16 to 20, all these challenges will culminate at one place, and there will be a big gathering during this week. So next slide, please. During the main summit days, I will talk subsequently also what will be happening in the summit week. So regarding the objectives of the Impact Summit, as we see the AI resources, like maybe it's a compute or data sets and others. Say currently the compute resources are within few hands, or few concentrated at few places. So, but to leverage the AI for each and everyone, for every citizen, for people, for everyone in this world, that needs to be democratized. So if the global south have the access of these resources, only they can move forward. So one of the objectives is to democratize the AI and bridge this AI divide among the developed and the global south world. Another objective is to develop the indigenous solutions, as India is like a use case capital. So we are trying to solve the use cases and the problem statements of the country and make the indigenous AI solutions. That's the another objective, and also develop the AI for good solutions across various sectors like healthcare, education, agriculture, etc. The another objective is, which we cannot forget, and which is the backbone or the starting point of these summits, is the safety. So another objective is to make the global standards, AI governance models, etc. So, and align the developed world and the global south world with these standards and the governance models, so that we can move forward, taking all along. And the final objective is to become empower and become the voice of the global south. Next slide, please. So as far as the scale is, this is just to showcase what is the scale of this present summit, in which more than 100 countries are invited, and more than 100 countries will be represented at various levels, including head of the states, ministers, and the executives level. And more than 50, instead, I can say more than 100 global AI leaders, which include the CXO levels and the other global AI leaders, will be participating in the summit. Till our initial objective was to have 200 high impact side events, but to lead to the summit, we have already done around 360 pre-summit events, and around 400 to 500 events will be organized during the summit. And we are targeting more than 50 tangible deliverables during the summit, and this is the working group meetings are the part of this process. As far as attendance is concerned, we are looking for more than 40,000 in-person attendance in the Bharat Mandapam, the venue of the summit, and more than 1 lakh, I can say even more than 1,50,000 total participants in attendance in the pre-summit and in the expo and in the main summit in Bharat Mandapam. Next slide, please. So these are the pre-summit events. The overview of these pre-summit events is the pre-summit events are being held by various entities. It includes academia, it includes industry, it includes civil societies, think tanks, even the foreign governments who are hosting these pre-summit events across the various topics of the AI. And these are in the various formats like roundtables, fireside chats, panel discussions, showcasing of the various innovative solutions. So till now, more than 360 pre-summit events have been organized, and many more are in pipeline. The events are organized in more than 20 countries, covering, and in India it covers 18 Indian states, UTs, and 60 plus cities. Next slide. These are the glimpses of the pre-summit events to showcase the diversity which we are targeting or which we are following in these pre-summit events. Next slide, please. Next, please. So as I already mentioned, we have few flagship events in which there are 3 innovation challenges. One is the AI for all, which is to provide support and to identify the best startups which are making impact in the AI world with the various use cases. And one is for the AI by her, that is the challenge for the women, and one is the Yuva AI challenge that is focused mainly for the college students. In this, around 4,500 applications we have received across the world, and under the 3 challenges. And the winners of these challenges will be showcased during the Impact Summit from 16th to 20th, mainly on 16th and 17th Feb, and the monetary awards will also be given to the winners. Next slide, please. And also, these winners will be given opportunity to showcase their solutions in the pitch fest, where they can pitch their solutions to the investors and seek investment. The another one of the flagship event is our research symposium, which is being organized in collaboration with IIIT Hyderabad, and it talks about the how research is making impact on various things, what is the role of research, and it showcased the high-level research papers from the global south and from high-level dignitaries, which are mentioned here, like Jan LeCun, Demis Hassabis, Stuart Russell, Fifi Lee, they will be there. And in this, more than 250 applications we have received from the global south countries, which covers South America, Africa, and Asia, to showcase their research papers. So all this will be happening on the 18th of Feb in Bharat Mandapam itself. Next slide, please. Along with that, we are making the case books on various use cases in agriculture, health, education, women empowerment. In this and these use cases are being developed in the partnership of various organizations, in various international and even domestic organizations. Like with the World Health Organization, we are making the use case books for use cases related to health. With IEA, we are compiling the use cases related to energy. With UN Women, we are making the use cases for the women gender empowerment and the women empowerment. So similarly, in agriculture, we are making the use cases. In these use cases or case books are also open. We have invited the use cases proposals from various, from the citizens across the world who wants to, who have their who have built the solutions or applications in these areas, which can be included in this case book. Next slide, please. Along with that, we are, as I mentioned, we are making use case book for the education, AI, and accessibility. And also, we are coming out with these statements of the global AI leaders of various high-level companies, which will be compiled in this tech leaders vision document, which we are making along with the Niti Aayog. And last but not the least, along with the Joshua Bengio, we are making the AI safety report, and the history is it started again from the Bletchley Park. In the Bletchley Park, UK announced that they are setting up a safety panel, which will be chaired by Joshua Bengio, and they have come out with their first report in the Action Summit. An intermediary report they have published in the Seoul Summit, and the first report, final report, was published in the Action Summit. Now they are, Joshua Bengio along with us is working to in the second version, in the second report related to AI safety, that will also be launched during our our Impact Summit. Next slide, please. Other than that, we are having a Impact Expo, AI Impact Expo in the Bharat Mandapam itself. So more than around 300 exhibitors will be there. There will be country pavilions, which includes France, Spain, and other countries. They will showcase their solutions in Delhi. Other than that, there will be various showcase or pavilions from the global companies like Google, Google, Meta, and also the Indian companies like Infosys, TCS. And along with that, half of the entries are from the startups from the world and from the India. Next slide, please. So now we come to the working groups. So the discussions in this Impact Summit, which will culminate to the deliverables, are organized into the 3 pillars and the 7 themes. In the summit, our objective is to talk about the impact on 3 things: on the people, planet, and the progress. And the discussions among these 3 are distributed in the 7 working groups, which includes, first is AI for economic growth and social good, where we are talking about how AI is making impacts in economies of the world, of the individual countries and the organizations, and how we can leverage it to take our economic growth further, and how AI is impacting social good initiatives. The other working group is the democratizing of AI resources, in which is our first objective. We talk about how to democratize the AI resources, how to make available the AI compute to India and to the other global South countries. In the third theme, we are talking about inclusion for social empowerment, how we can include other communities of various, it includes gender, it includes disabilities and other, so that how we can leverage AI for these social social empowerment of these. Other than that, as we see, this safety, we cannot maybe we have shifted from safety to the innovation, action, and impact. But the safe word, or you can say trusted AI, is a word which we cannot forget at any stage. It cuts each and everything horizontally across across everything. So definitely we will talk about trusted AI also in the working groups, in the Impact Summit through this working group. And this is being led by IIT Madras. And as we have a fear of like job losses and et cetera. So those discussion which relates to the human capital, how AI can be used for leverage, for means how AI can be used for this skilling of the people, how, in which area we can skill them, how we can uh, how to stop or how can we manage the job losses. All things will be discussed in this human capital. In the science, we are talking about how AI can be used for like drug discovery and like for mining and the other things, means how AI can support in physical sciences and the basic sciences further. And in the resilience, innovation and efficiency, in today's working group, we are discussing how to make AI sustainable, how AI can use further for the means like for the climate, to support the climate, and also what can we do to make AI more energy efficient. So these are the 7 working groups in which we are discussing all the various aspects where AI is making impact. Next, please. So these are the glimpses of the working group meetings. In this, around more than 60 countries and 20 international organizations are being participating. And also these working group meetings are being held virtually and physically. In this 3 meetings of each working group, we are having virtually, and 1 hybrid working group meeting we are organizing. Next. So this is the summit week. In this summit week, we have the final culmination of the innovation challenges and also the our research symposium on 18th. Other than that, all our knowledge compendiums, the case books, Yoshua Benjo AI safety report will be released in the Impact Summit. Other than that, there will be various high-level panel discussions, talks of the global leaders, and the roundtables, government roundtables and the private roundtables will be there. And other than that, there will be a summit dinner, and interaction with the various leaders will be held during 16th to 28th. Next. Thank you. So this is the short glimpse of IndiaAI Impact Summit and what we are trying to do with this summit, with this initiative. Thank you all.
Thank you, sir. So there is a great poet in Kannada called D.V. Gundappa. He quotes this one beautiful kagga. It goes like, ಹುಲ್ಲಾಗು ಬೆಟ್ಟಡಿ ಮನೆಗೆ ಮಲ್ಲಿಗೆ ಆಗು ಕಲ್ಲಾಗೋ ಕಷ್ಟಗಳ ಮಳೆಯ ವಿಧಿ ಸುರಿಸೆ ಬೆಲ್ಲ ಸಕ್ಕರೆಯಾಗು ದೀನ ದುರ್ಬಲರಂಗೆ ಎಲ್ಲರೊಳಗೊಂದಾಗು ಮಂಕುತಿಮ್ಮ. If you look at how Impact Summit has grown from the day one, it's exact same line. They found so many difficulties in this world. They found a lot of pieces disconnected, and they figured out, okay, if India is not going to drive this, it's never going to be driven by anybody else. So that's how we correlated everything, and today we have India Impact AI Summit happening. So again, I think it's a warm welcome for everyone to join the summit. At the same time, it was, if you have not visited the website, just Google it right away, and you will see bombardment of knowledge coming out from various places. Today morning when I was scrolling down, I gave my ChatGPT this website and said, scrape everything. It failed to do it. I have a premium version, by the way. Still, it failed to do it. It's secure, sir. Thanks for that website. But at the same time, the kind of information being fed throughout the time, every day, everything's what's going to happen, you're able to see there. And the kind of hard work went through it, it's totally amazing. And thanks to the whole community who are driving this thing happen. And special thanks for Shashank sir for addressing the gathering with those information. So with that said, I request all the dignitaries to join us for a group photo. And yeah, in the meantime, is AI overloaded? No answers from anyone. Already like, okay, we are scrolling down, we'll see. Lot of resilience is yet to come. That's what we are going to have in the upcoming sessions. So just post this, we'll be having a short break. Before that, I request Vinod sir to provide a token of appreciation from the IISc front to all our dignitaries. Okay. Now we have officially come to the conclusion of the first part of the session. We have amazing events lined up. So we have a tea break and coffee break at the moment. It's always said, great ideas comes over coffee. So it begins with the coffee. So we have a networking break there.
So the audience can join us for break on the third floor. The rest can move to the left of the auditorium. Please be back by 11:30 for the next session.
No, I think the person.
Timbro. Request everyone to please be seated in the auditorium. Please be seated. We will be starting our next session soon. Please be seated. We now begin our session 1, focusing on overcoming data compute challenges, a research viewpoint. Dr. Y. Narahari, Honorary Professor, Department of Computer Science and Automation, formerly Dean, Division of Electrical, Electronics and Computer Science, formerly Director of CBR IISc. I invite our session chair, distinguished academic and leader in system science, to take the lead.
Thank you very much for this opportunity. Welcome to all of you for a very, very important session. This session is going to be on data and compute challenges that need to be tackled towards efficient, scalable, and impactful AI systems. And this session will look at the research perspective on data and compute challenges. We have a panel of very distinguished speakers in this session. We will have a keynote address followed by 3 invited talks. And the keynote address will be given by Dr. Chris Gopalakrishnan. And I'm delighted to invite Dr. Chris to deliver the keynote talk. He really does not need any introduction. He is one of the co-founders of Infosys, rose to become the CEO and MD at Infosys Technologies. In the past 15 years, Chris has taken philanthropy for science, technology, socially and nationally relevant projects to unprecedented heights in India. He has envisioned and also championed multiple high-impact S&T initiatives in the country. He's currently chairing the Governing Council at IISc. He's also chairing the Board of Governors at IIIT Bangalore. He's chairing the Vision Group on Information Technology for the Karnataka State Government and also chairing the Reserve Bank Innovation Hub. So let's welcome Chris to deliver the keynote talk on a very, very important topic, Resilient AI, India's Global Role. Over to Dr. Chris.
Thank you, Professor Narahari, and good morning to all of you. Thank you for inviting me to this very interesting session. First, let me compliment Government of India for taking leadership in organizing. They were partners in organizing the Paris Summit and now the summit in India. And from what I saw, it's looking to be a grand event. The focus of my presentation on from scale to resilience is going to be on a longer term view. And I will come back to why a longer term view and the opportunity that exists for all of us, and especially in India, how to shape this technology that's impacting every aspect of society, every aspect of business, every aspect of science, engineering, technology, etc. How can we be part of shaping this? Let me start with an interesting slide. I deliberately chose to include this. Because we need to look back to understand where we are, understand how things are going to change, and this is how humans looked at mobility itself, right? You have different forms of going from place A to place B, and it didn't evolve with a single model. It didn't evolve with a single paradigm. There are multiple paradigms. From the automobile to the steam powered train to electric powered train, then flight. Flight also. If you look at again different forms and factors, and ending up with rockets to launch to other planets and things like that, right? So it didn't really it didn't really take just one form, and it took many years actually. And the fuel systems changed. We went from electric to internal combustion engines to electric. The trains started with steam. Now we are going to have electric planes and rockets. India is also looking at 3D printed rockets, right? So the evolution takes many different forms and many years actually. Something that is fundamental will take long periods of time. Let me look at digital computing itself, and to understand where we are in AI, we need to look at how digital computing evolved. And many people here probably won't recognize any of these things, but may understand a little bit on the diagram on the right side, which is based on the Intel 8085 architecture, the von Neumann architecture. And this is a fantastic, if you're a teacher to teach von Neumann architecture and digital computing, this is a fantastic diagram because many of the components are actually there. The program counter, I can't see there actually. The instruction register, the different registers, etc. And the reason I say this is memory is treated same as data, program is treated the same as data, and you have a CPU, you have an I/O module, and that drives the entire architecture, how it progresses, etc. Now, what we have done is taken this, and on the right side bottom is the Apple Lisa computer, which is the first one which used a graphical paradigm. Okay, so we have taken this architecture, and then in order to speed up the PC, we introduced the GPU, right? And of course, GPUs have progressed significantly with the NVIDIA coming in and putting the CPU inside the CPU and GPU together and creating a board for that, etc. That is what is driving AI today. So we did not create a ground up architecture for AI. We repurposed digital computing architecture, which is a finite state automata based architecture. Of course, we repurposed it for from a calculating machine to have branching, have logic, have all that stuff, and then we repurposed something that is a sequential machine to become actually a logical machine. That's what we did when we invented the computer, and later on that computer was repurposed for AI. Going back to the basics probably will tell you that this is probably not the best architecture for AI, right? So what happened? Now we have brute force found a solution for machine learning, etc. It's a brute force solution for AI, right? And so this is, in terms of context, I want to say that, today's AI paradigm is increasingly constrained by compute data and energy because we have taken a paradigm which was not right. And this is what we have been doing for human history, right? Moving from place A to place B using aeroplanes, etc. We didn't use the same paradigm that I think one slide is missing in this. Anyway, forget it. It doesn't matter. There was one slide which was supposed to be there, but missing in this actually, because I had a slide on humanoids. Okay, and if you look at the paradigm of humanoids, and the first robot that became commercial is the iRobot, which is a vacuum cleaner, right? Useful. You should look at the architecture of that. It's very, very interesting. It's the simplest form of robot you can think of. It can only go in one direction. If it has to turn, it has to stop and rotate and then move in another direction. It has a sensor to just sense two things. One, any obstruction in front of it, and second, where is the charging station. So sensor that has only two things. You know, it's amazing that simple things like that create a robot. Basically, we have to go back to the basics to think about AI and the future of AI. And I'll come back to this because some of those elements are here in IISc. That is what is actually, to me, a great opportunity for us to change the trajectory of AI. And we have to take that, we have to take advantage of that opportunity, and we have to make that indeed happen. Because the cost of building systems are increasing, barriers to adoption, especially for 90% of the world, right? Most of us are dependent on 4 or 5 companies in the world. All the data is in with few companies. And when it comes to a country like India, where we represent, somebody was mentioning it, 1/6 of the world, right? 16 to 20% of the world. And we generate huge amount of data, and we're giving away that data free. The next AI race won't be won by bigger models, because the different paradigms or different applications will require, I believe, different models. Small language models, inference at the edge. If you look at autonomous vehicles, probably the model that's required may be very different, because that's a specialized kind of activity. So I strongly believe that we are at just the beginning. If you think about the Gartner's S curve, we are probably on the beyond the first peak, where there was a lot of excitement, lot of adoption, etc. And now the disillusionment is setting in. And then gradual increase will happen when a lot of applications come online. And this will be probably a next, an activity for the next 30 years. Digital computer, 1945 to now, that's about 70, 80 years actually. So it will take that kind of time for AI to become widely used. And a lot of changes will happen. The key players who are there today may not remain as they are. And in the computer revolution, I can tell you that many of the companies have disappeared. Digital Equipment Corporation, Compaq, so many of these companies have disappeared, with the different models and things like that. So it will be won by resilient AI. This is a force fitting that we did in preparing this presentation, because the word resilient was used because we were asked to use the word resilient. So, and I'll redefine resilient a little bit later. I think India's moment, an opportunity and a responsibility to help shape this shift actually. So, the dominant story has been scale. Throw more compute at it, more power requirements, more data, and that's how we have been going at it. Bigger models means better models. But resilience is a different goal. So resilience is defined as high performing and affordable, energy efficient, reliable, inclusive under real world constraints, supporting multiple languages. It has to be repurposed for different applications. It has to be repurposed for use at the edge, use at autonomous vehicles, everywhere actually. So can the system work with limited infrastructure? Can it serve many languages and literacy levels? So, natural language interface, vernacular language interface, etc. Can it be trusted in high stakes environment? can it remain robust as the context changes? And will it be affordable and accessible to the world? And looking at tokens per watt per rupee or per dollar, whatever it is, to learning outcomes per watt per rupee. I know this is very important when you want to look at affordability. Actually, is the application affordable? Can it be used by all the people, all the 8 billion people in the world? Similarly, for intelligence, it's clearly now understood that one-time intelligence fails. You have to continue to train the models, repurpose the models. The models themselves are changing, and looking at designing for durable learning. Clearly, we want to embed this in daily tasks so that the learning is continuous as we go along. There is graceful degradation. So this is like a controlled denormalization in the relational databases, right? We have to look at how do we look at it where there is low connectivity. Maybe there's no connectivity at all offline. Can we use these models? Trust preserving. Can humans override the machine when needed, etc. And we can actually look at measurable improvement over time, which is also visible to the user because the user is paying for these things. So we need smaller specialized models for domains and languages rather than one monolith. Of course, we have now got multiple models and we will probably have many more models actually. We need to look at efficiency techniques. There are many mentioned here so that inference becomes cheap. Grounded systems using retrieval and verified sources. So this is actually very, very important to build trust in these systems, and not just throwing simply data at the problem, at the machine. And we have to look at on-device AI edge where appropriate. So privacy, cost, latency, resilience when connectivity is weak. All of these things we have to look at. And instead of looking at as was mentioned in the previous slide, rather than looking at tokens per rupee, we have to look at cost per task, learning per task, outcomes per task, energy per task, robustness, reliability over time. So here, I'm just mentioning couple of things that are happening here at Indian Institute of Science, which I am very excited about. The team researching on materials like gallium nitride, two-dimensional materials like graphene. So we need to even rethink, semiconductor itself, because when you want to think about low energy, low cost materials and low cost quote unquote systems, transistors, etc. We have to think about new materials, and a lot of work is happening here at Indian Institute of Science. Cutting edge applications in power devices, optoelectric memory, neuromorphic computing, quantum applications. Again, we need to look at all these things actually as we go forward. And this is the opportunity for us to do that. Think about what is going to happen in the next 10 years, 15 years, etc. And as I said, there are multiple form factors for mobility. There are multiple repurposing that has been done using a digital computer to now use it for. So we did repurpose, use it for AI applications. Maybe there is a ground up way we can build specialized hardware for AI. And that's what I believe the opportunity is actually. Extending the capability of memory devices to work on biological and synaptic principles and bridge the gap between biological neural networks and their artificial counterpart. You know, it's very interesting. You know, I always look at nature and learn from nature. A neuron is nothing but a very simple thing, on-off kind of circuit, but it has various states. But it's a simple biological construct, the neuron. It has electrical and chemical signals, capabilities. But that neuron has not changed in billion years. The smallest animal to our brain uses the same neuron actually. But then how do we get the intelligence that we are supposed to have? Right? It's very interesting. So we need to study this actually. That simple neuron has been used to create human intelligence, animal intelligence, different types of intelligence. The same neuron has been used. Only thing is we have 80 billion. So maybe nature decided that throw power at the problem, it will solve the problem. But you know, we have to go back to these principles and see whether we can learn from that. The team in the Sense Lab, I think it's a Sense Lab, right? Shritosh and Navkant Bhatt, etc. They're working on Memristor. I strongly believe that the work that they're doing will have significant applications in strategic sectors, in edge computing, wearables with strong AI capabilities and things like that, because it's low power device, etc. And they have actually proven that it can be used for metrics manipulation, etc. So clearly, you know, there are new form factors that are possible. There are new materials that can be used. And I strongly believe that in order to build resilient AI, these will have to be taken forward in a big way. And I hope that this AI summit, we can showcase these things and get research funding from international philanthropies and organizations. Just a shout out for the unique opportunity that India provides, and then I'll stop here. You know, India brings constraints to the problem. You know, when you look at a developed economy, constraints are very different. You know, the constraint of energy efficiency is there, but they throw money at the problem, right? We can't do that actually. We will have to think about energy efficiency in a much more serious way. Compression, specialization, routing, you know, we have to think about different models. We have to think about benchmarks that reflect reality. You know, the amount of data is huge actually, but still we have to think about how to deploy that properly, and we have to think about governance, etc. So I strongly believe that India is a laboratory for the world. India will allow you to develop better models. The constraints that India imposes, the multilingual requirements, the cost requirements, etc., power requirements, affordability, access, all of those will allow you to create better models and the right models for the world. I strongly believe that the right models for the world. Again, you know, some more constraints at the scale. Constraints are the ones which will allow you to improve the model, right? Because it will force you to rethink, and it will force you to actually figure out, you know, what you need to do. You know, the first Unix-based multi-user personal computer was developed by Wipro, because we couldn't use the PC as a single-user device, which was not affordable. So the constraint forced them to develop a multi-user personal computer before anybody else did in the world. But we didn't take these things forward. I think we have to learn from all these things actually, and use these constraints as the opportunity to develop better models. And this is what I believe the opportunity for India is. And I think we need to leverage this AI summit to project this, to actually kickstart these efforts actually. And I believe that India can become the proving ground, the laboratory for resilient AI. and co-creator for the next global paradigm. I'm going to stop here and maybe leave it here. I believe that we need to form a consortium, which is academia, industry, startups, global partners. We will have to do open science and open models actually. Shared evaluation toolkit, real deployments and feedback loops, and compute commons. The DPI approach again is very important. I didn't talk about DPI. That's something that we need to take forward to the AI world also. Thank you all very much.
Thank you. Thank you, Chris, for outlining a breakthrough agenda for India and also the research community for resilient AI. We have time for a few questions. So whoever wants to ask a question will have to come near one of these mics, which are strategically placed. One mic is here, another mic is there. And you can ask your question, make the question very brief, announce your name, and then ask the question, make it very brief, so that, you know.
Any questions?
Yeah. Good morning, sir. I'm here.
Yeah, go ahead.
How you can leverage AI in good governance, sir? In government accountability? We can put some light on that.
Yeah, see, applications of AI in government will be to look at data and look at inferences from the data. So, for example, just simply asking the question, are the benefits reaching the intended people, intended citizens? Good governance in Bangalore means, can we use AI to manage traffic better? So many opportunities are there to deploy AI. The opportunity is to leverage the large amount of data that we have and come up with inferences for better management and better models, or even inferences from the data, patterns from the data, etc. Lot of, I feel it's a no-brainer actually in that sense. Go ahead.
Hello. Yeah. Sir, I'm Sandeep. I represent FSID in IISc. I have been fortunate to be an ex-Infosian too. My question is something in the last line that you said, compute commons. What is meaning of that? Is it like an open benchmark, open model, or something that you have in mind?
So first of all is data, right? Now there is an effort, I think IISc is also involved with that actually. Professor Inder Gopal's group, I don't remember the name of the group now. IUDX, right? They have now come out with the standards for creating common databases for public use, research use, used by startups, etc. All government data is being deployed as these databases and things like that. So, data as a DPI is the first thing that I can think of. Second is open models. Open source models or open models that can be deployed for various applications and things like that. And then as you write agents and things like that, these agents also can ride on some common infrastructure, which will be the DPI, DPG, etc. Just like UPI has a common layer, you can have the agent also using this common APIs and things like that to access. So for example, all the credit data is now being put into universal lending interface by the Reserve Bank of India. So anybody who wants to create a loan product can just go to this data and get all the information that's necessary to originate a loan. So such common databases and common APIs can be created.
Yeah, last question, please. Yeah.
I'm Shalab from IUDX. So actually, one of the things that you mentioned, India is very unique because of the diverse data sets it has, right? And we're seeing a lot of international companies actually trying to get access to that data. For example, OpenAI released a health stack where you can upload your.
Please make the question very brief.
So how do we preserve that data within India so the Indian company can actually benefit from it because I don't think we are ready yet to fully utilize that data, right?
See, we cannot say, don't use this application. If a citizen wants to use an application, they are free to use it. Only thing is, we have to educate them, and government will have to come up with regulations which says that, and this is what our committee proposed. Anything that belongs to citizens, even if, let's say, a company collects it and uses it, it must be also available for others. It's not their proprietary data. So if I use any company's name, it's just as an example. I'm just saying company XYZ is collecting that data. They can't use it exclusively for improving their models or their programs. They'll have to make it available for others also, so that it's truly a digital public good. So for example, map data, right, now must be made available for others also to use. Traffic data must be made available for others to use. You can collect it, but to use for your application, but it must be available for others also to use.
So let's thank Chris for a wonderful talk and urging India to lead from the front and become a global leader in resilient AI. And thank you. Our next invited speaker is Dr. Venkat Padmanabhan, Managing Director, Microsoft Research India. Venkat is known worldwide for his influential research in systems and networking. He is a PhD from the University of California, Berkeley. He is a fellow of INAE, fellow of IEEE, fellow of ACM. He is a recipient of the Shanti Swarup Bhatnagar Award. And most importantly, he is the recipient of multiple Best Paper and Test of Time Paper Awards. So let's listen to Dr. Venkat Padmanabhan now. Let's welcome Dr. Venkat. Yeah.
And the India angle, opportunity, and so on, because it will allow me to jump right in. Right, I will provide you a glimpse of work that's happening at Microsoft Research, particularly in Microsoft Research India, that intersects with some of the themes of this workshop. And efficiency is what was in the title of the workshop. I think I added efficacy. I think Chris redefined resilience. So I just added efficacy to talk about what it takes to take AI and make it actually produce results and make it useful for people. Right. So this is a AI stack picture that it's not an official diagram, something that I made up to just sort of convey that when we talk about AI, often the focus is on models. How large the models are getting and how, but there's a lot more to actually getting AI working than just the models. I mean, there is the underlying infrastructure, your compute infrastructure, hardware as well as software. there is what I'm calling as the intelligence infrastructure. The models are part of it, but things like retrieval, right? Unless you feed models with relevant data, they're not going to produce the desired results, right? So in some sense, that is there. There are applications, there is policy, and there are cross-cutting issues, things like security, extremely important. And what we're calling a science of AI, not to be confused with AI for science. This is really understanding why these models work and how they work, right? We know that they work empirically, and getting deeper insights can help us. Now, when I look at the work we do at Microsoft Research, particularly in India, there's a lot that we do that I would call as geo-independent. This is work that could be happening anywhere. We just have the people, the talent, the ideas here, and we do that. But there's also work we do that is inspired by our location in India, right? The problems we see at our doorstep, and then the opportunity to connect AI and technology with those problems and make a dent is something that excites us. And so we do that as well. So let me sort of dive into set the stage here. So obviously AI infrastructure is growing by leaps and bounds. And I just arrange these headlines in increasing order of dollar number. So it starts with 80 billion, but that's nothing. It ends with $1 trillion, right? So in some sense, the amount of investment is staggering. And companies like Microsoft and Google essentially have become like the large capex companies of the old era, right? The things that were quite unimaginable are happening now. Now, given that kind of investment, obviously efficiency is extremely important for reasons of cost, for reasons of energy, right? And sustainability, because if you have so many GPUs, so many $1 billion of GPUs that have to be fed with power to make them work, you want to make sure that you don't destroy the planet while creating your AI, right? So now again, AI efficiency is not a single thing, right? There are multiple things here, and I've tried to organize this by saying, okay, at the bottom there is the hardware element, right? The GPUs, for example. You want to make sure that they are utilized effectively. Essentially, make all the flops count, right? Don't idle these. A second thing related to compute is offload, right? Today, the device in your pocket, your phone or your laptop, typically has what's called a neural processing unit, an NPU. We might as well use that rather than let it idle, right? So what does it take to use that? I will talk about that. Then, everyone, of course, talks about the large models, the frontier models with, trillions of parameters, and they're amazing. But depending on what you're trying to do, a much smaller model might be just fine. And obviously, a much smaller model also means something that's more efficient, that's less expensive. And finally, I think this will please Chiru. He was asking about energy. Leveraging renewable energy in the context of AI compute is an interesting opportunity, right? And I'll talk about that as well. Okay, so let me just it's a collection of slides, just try to illustrate these things. So when you look at GPU utilization, and I think it's like Transformers 101, essentially you have these layers of the transformer, and then there is computation that happens in the self-attention layer, and then what's called the feed-forward network. But at a very high level, when you ask ChatGPT a query, what you're giving as part of the prompt gets processed in parallel. That's the blue stuff here, right? So that's the query you're giving. And then it produces the answer, essentially token by token in an auto-regressive manner, right? And so in some sense, that's a sequential process. So what happens is that the blue stuff is pretty good at utilizing the flops of the GPU, right? Essentially, it is a compute-bound processing. But the token by token decode tends to be bottlenecked on the memory, because you're producing one token at a time, and I think next slide probably just briefly illustrate that. And therefore, you're idling your GPUs, and that from an efficiency viewpoint is not good. And the fact is that compute operates much faster than memory bandwidth, and so that's the issue. Okay, this clicker is not very reliable. Okay, so we have done some work to essentially make what is memory bound, or to point that way. Okay, thank you. Oh, the machine is there. Okay, thank you. Okay, so yeah, let me just jump forward, right? Yeah, so the other thing is, okay, this is like essentially looking at sort of one GPU. But when you have, first of all, I didn't mention this, but today, a lot of the cost and a lot of the energy is going in inference. Because, the models are trained, and of course, they're expensive to train. But given that there are real applications, once you train it, you're going to use it many, many times, right? So inference dominates. Now, when you're doing inference on a large model, the model may be so large that it cannot fit in the memory of a single GPU. Therefore, then the inference has to be spread across multiple GPUs, right? Whether in the same node or across nodes. And so the communication between these GPUs can also become a bottleneck. So from a systems viewpoint, those are things. So I think I'll just, in the interest of time, I see the counter is either it's running very fast or I'm going slow. So essentially, there is matrix multiplications happening all over the place. And in general, the larger the matrix that you can multiply, the more efficiency you get. So if you can accumulate a bunch of things and then do the multiplication, that's better. So I'll leave it at that. So what are the kinds of things that you can do and what we have done, right? On the left is the picture today. You process the prompt in parallel, and then you do this one at a time decoding for possibly multiple requests, and you're idling the GPUs. Instead, you can take your prompt, slice it up, and pack it with the decodes. We're calling it chunked prefills. That's the idea, right? So essentially, prefill is the parallel initial part. We chunk it up, and we mix it up with the decodes in such a way that you can utilize this much better. So this idea of chunk prefill that we worked on, maybe my colleagues worked on a couple of years ago, is now adopted widely, right? For example, VLLM is an open source serving stack that came out of Berkeley, I think. And it's part of that, and it's part of other stacks as well. So it's had quite a bit of influence, also published in a major conference. Now that works for the so-called feed-forward network, but where everything is being multiplied by the same matrix, so it's sort of easy. But at the attention layer, it is hard to do this kind of chunking and repacking. So there, we can do sort of parallelism at the level of these thread blocks, or CTAs they're called, where you take a streaming processor and give it a combination of prefill thread blocks or CTAs and decode CTAs, so that in combination, the compute and memory thing is balanced. It utilizes both of them in a balanced manner, right? So at a very high level, that's the idea. So you can utilize both of these. And finally, when you get to this distributed inference, where the model is spread across multiple GPUs, typically what happens is that you're processing this batch, you're doing the compute, and then you have to do a communication, what's called all reduce, where the partial results from multiple GPUs have to be brought together and shared and so on, right? And when that is happening, you're idling your compute because the communication is happening. So again, from a systems viewpoint, what you can do instead is you can split your batch into two and process them in a staggered manner. So essentially, while one of them is doing compute, the other is doing communication, and you have to balance this. Now, of course, there's a lot of intricacy here, so I'm just giving a very high-level picture. And so you can avoid this compute communication tension that exists. So anyway, this is a quick set of ideas that you can do. There are many other things that we have also worked on and others are working on. So the second thing is offload, right? So I talked about using GPUs more effectively. The second is offload. What does it take to leverage the GPU that's in your pocket, in your phone or in your laptop, right? There are many things, but one thing that you have to worry about, and there's a lot of opportunity, the GPU sitting idle, might as well use it. But you have to worry about security, right? So if you have a model, you may not be comfortable shipping that model to an insecure device, which is the client device, where the IP might get stolen, right? The model is your IP, and you don't want that to be stolen. And even if it is an open weights model and you don't worry about IP, you have to worry about integrity. How do you know that the client device is actually executing the model that you intend to execute, as opposed to doing something else, right? So you have to worry about both model protection and integrity, right? And so we have looked at both of these. And the intuition, for example, in the case of model protection is, the model may be very large, but you can decompose the weights into a relatively small critical part and a much larger non-critical part, right? So at a very high level, like 20,000 foot level, you can think of it as the most significant bits. A handful of most significant bits, if you hide, the rest of the large number of less significant bits can't do much damage, right? It's not obviously, it's a loose analogy. So my colleagues have worked on this, and they've demonstrated that, in fact, this WC, which is the critical part, is quite tiny. So the idea is that you keep that in the secure location, like the cloud. You compute that part there. You do the bulk of the work on the remaining bits on the insecure device. So you've shipped out bulk of the work, but you've made sure that the important bits are still with you. And for integrity, I don't think I have time, but essentially, again, there's some clever ideas leveraging some work from 50 years ago by Freivalds in 1977 to essentially allow a probabilistic way of checking that the computation is actually accurate. So if there's interest, I'm happy to tell you more offline, or better still, point you to my colleagues working on this, because they can answer this better than me. Okay, so let me speed along. The third one I talked about is small models. You don't need the giant model for everything. And so I would say Microsoft Research globally, not just the India lab, has been among the pioneers in this idea of SLMs, or small language models, where you're talking about models with maybe a few billion parameters where essentially, we are scaling or we are pushing on the frontiers by working on the quality of the training data, right? Essentially curating the training data in a way that you can get great results for the task at hand without having to scale the model, right? So we have this thing called the 5 series of models, and there's been a series of these models, and that continues. Now, one thing that we did in collaboration with our colleagues and some folks, in the India lab working with the global set of labs, is build a small language model for automating computer use, right? So think of AI navigating a website, selecting your flights, and then booking the ticket for you. It has to sort of figure out how to navigate, where to click, what to click, what drop down to work on, and so on, right? And so we built this model, I think, 7 billion, so it's a fairly small model. This was announced like 2 months ago and got quite a bit of press. For example, in benchmarks, we found that this rivals much larger models like GPT-4o and so on in terms of accuracy. And that's what this chart also shows, where you're looking at accuracy versus cost. The FARA 7B is the leftmost curve here, right? So this just shows that LLMs are great, but they don't necessarily need to be the solution for everything. And finally, getting to power, obviously renewable energy is something that is growing, particularly in India. As AI energy consumption skyrockets, you have to think about the consequences of that from a sustainability viewpoint. So companies like Microsoft and other large companies have made commitments on being carbon neutral or carbon negative in the next few years. So the question is, how do we get there? Now, it turns out that the renewable energy itself is not the bottleneck. The bottleneck is the transmission capacity. You might have a wind farm or a solar plant somewhere. Getting power transmitted from there to where the compute is the bottleneck. So then the question is, can we do this differently? So what my colleagues are working on is this idea of green inferencing, where instead of transmitting the power to compute, ship the compute to where the power is. Have micro data centers co-located with these renewable energy plants, and then figure out a clever way of shipping work to these, right? You have to deal with the fact that the wind is not blowing all the time, or the clouds may come and the solar thing may dip. So it has to be, it's not good for every workload, but there's plenty of workload. A good example is, you have a meeting, a Teams meeting, gets recorded, and then you can use AI to analyze it and so on. That doesn't have to happen instantly. That can happen, 15, 20 minutes or whatever. So you have some window of time. Okay, so I think my time is up, unfortunately. But anyway, so we are working on this. I did have a whole other thing on efficacy, but let me just sort of end with this slide where, in the interest of time, I will stop. But there's a lot of work we do that leverages our location in India, where we work with the ecosystem to identify problems and sort of work together with partners, whether they are startups or startups that we have spun out, like Karya and Digital Green, NGOs and so on. I'd love to sort of talk to people if there's interest on this. Thank you.
Thank you. Thank you, Venkat, for a very nice talk. Thank you, Venkat, for a very nice talk. Time for questions. We'll have time for 2 questions.
Thanks for a beautiful presentation. I have only one quick question. So talking about SLMs, right? So these days I see often people download these models in their systems and they build on their own. And the repetition of these kinds of SLMs happening, they retraining the model, leading it to an LLM again, is happening in a different way. Like big, large companies, including startups these days, they're just creating a wrapper out of SLM and selling it as a new startup and again taking funds. It's a huge fund. Okay, let's not talk about go there. But what is your take on retraining an SLM just because it is not fitting a one factor, rather than communities like Microsoft can build a community where we can actually add it as an agentic add-on rather than recreating the whole system. Any takes on this view?
Okay, maybe I need to understand the question fully, but if you're saying that you want to personalize it, or like let's say you want to customize the model for a particular use case, absolutely. So there is a lot of work, and we have something, for example, called Copilot tuning, where you can take an existing model and tune it for a particular role in a company. So think of the legal department at IISc. They may have particular terminology, particular things they want to do. Making it very easy for that kind of customization, absolutely we do, right? And that is something you could do for SLMs. You can even do it for larger models. So maybe we can take this offline, but I think you can certainly do what you're saying, and people are very much working on things like that. Sorry, redundancy in terms of work here you do? Okay, sorry, okay. Yeah, go ahead.
Please go ahead.
Sir, I'm Dr. Agrawal. I'm working as professor in CMR University. My question is, we know many LLMs have been launched by different big companies, and everybody is using LLM to larger extent, and lots of AI queries are floated on daily basis. So my question is, can we do something to reduce the carbon footprint which is generated from LLMs?
Yeah, so that was the last part of my talk, right? Like leveraging renewable power is certainly one way of doing it. There are research ideas like what I talked about, but on the commercial level as well, like, for example, Microsoft is building its 4th big region in India, in Hyderabad, and it is going to be, entirely water-free. It will be sort of closed circuit, air-cooled, and we're buying renewable power from Renew, which is a big company in India, and so on. So I think a bunch of things are happening, but there are also research ideas of shipping compute to data centers, which are not in production, but if we can prove them out in research, could also make a big difference.
But sir, we are talking about the scalability to resilient AI. So how much time, according to you, in India, especially in India, how much time it will take to adopt the resilience in AI?
I mean, it depends on what you mean by resilience, but the use of renewable power in this is already happening, and I would say in the next 5 years you will see massive shift, right, in leveraging renewable power for such compute. Yeah. Thank you.
Time for just one more question. Yeah, please.
Hi, this is Prodipto. I'm associate professor at Indian Institute of Science. So very quick question. So the complexity analysis and the energy usage that you mentioned, is it during training time or execution time?
Most of what I focused on was during inference, because that tends to dominate now in terms of cost. But there's work we have done on training as well. But this is all, what I talked about is all inference.
Thank you.
So, yeah, just one more question. Quick question.
Yeah, thank you, Venkat. Wonderful presentation. Thank you. A quick question. Considering that we are moving a lot, globally from LLMs to more, reasoning-driven, sort of, models and or objective-driven architectures, which I presume requires a lot more energy, at least 30, 50 times, than what it is. Do you think globally we are looking at this problem proactively rather than trying to solve this, once these models actually proliferate?
No, I think people are very alive to the reality that, the number of so-called thinking tokens far exceeds the number of actual output tokens that go out, right? So people are very much looking at it. And when we look at, planning for energy and so on, that is very much accounted for, yes.
So excellent talk on 4 extremely innovative ideas for AI efficiency and efficacy. Let's thank Dr. Venkat Padmanathan.
Thank you. Thank you very much. Thank you.
Thank you. Our next speaker. Our next speaker is Dr. Pratik Jain. Pratik is currently distinguished scientist at Google DeepMind. He's a PhD from the University of Texas, Austin. He's widely known for his foundational research in efficient and elastic architectures for large language models, scale and non-convex optimization techniques, and also in resource-constrained machine learning. These are all topics extremely relevant for today's discussion. Pratik is currently leading the machine learning and optimization team at Google DeepMind. He also co-leads a very strategic team, long-term model research for Gemini. He's going to talk to us about AI at Google, Matryoshka structure, adaptive models. Over to Pratik for his talk.
Okay, all right. Yeah, very nice to meet you.
Let's welcome Pratik.
Thank you so much, Professor Narahari, for the introduction, and thanks to Chiru and all the organizers for having me here at this wonderful event. I must say that Chiru has put me in a tough spot, asking me to not only follow Shri Krish, but also Venkat, who is like an inspirational research leader. And I have had fortune of learning from him for almost 10, 11 years. So today I'm going to talk about bringing adaptivity in large language models. So to sort of set the stage, let's first look at how machine learning was done in, say, 2016 versus how it is done in 2026. By the way, just in case you are thinking that I made this amazing slide, I did not. I just relied on Nano Banana to sort of beautify my very sort of bare bones slide. Anyway, so in 2026, the approach was, while deep learning had become a commodity, it has become very popular. Still, the general approach was, let's take a problem, let's figure out what are the accuracy requirements, what are the deployment constraints, how much energy we want to spend in solving the problem, how much latency we are willing to have, what kind of throughput or queries per second we would want to address. You take all of that, you then collect some bit of label data, and then you design a neural network just for your task. You will say, okay, so for my current accuracy requirement, for my latency requirement, for my power requirements, I have this very specialized neural network that I train. I will train it, I will validate it, and then I will go and deploy it, right? So that was the pipeline. And while this pipeline was successful, still, as you can see, it had a lot of steps, and you can get sort of bogged down by any of the steps. Even defining many times the problem was hard. Collecting data, training models, deploying models, it was a challenge, right? Life has changed significantly. We are in 2026, where we are in the generative AI era, where all we need to do is think of a vague problem specification, maybe cook up a few examples, give it to a large language models like, say, Gemini, and that's it. The Gemini will start sort of solving your problem in many, many cases, and you can just use the standard, the deployment framework, to go run your models. So that's great. So your time to sort of thinking about problem to going and actually deploying it, it has become really, really short. But we are paying a price, which is that we are now relying on this one single foundational model to go solve our tasks, right? And these tasks might be very different. These tasks might be super, super complicated tasks, but they can be very simple tasks. It could be a task as simple as sentiment. It might be as simple as a sentiment classification. That, okay, I have this review of my product. Is the sentiment positive or negative for this product, right? So because of that, now what happens is one single model is serving these very different kind of tasks, which means that it will not be able to sort of cater to the desired latency or cost or power requirements of each of these tasks. Right. So the idea that we are bringing here is that can we bake adaptivity in the model itself so that at test time, so you can follow the same recipe. You can still build one single foundational model, but within that model, you have so much adaptivity baked in that you will pick up whatever required part of the model for your individual task. So if your task is very simple, you maybe pick a very, very small part of the model and just pass your data or query through it. But if the task is very challenging, like solving maybe an IMO problem, you would want to use then the full model in its full strength. All right, and to do this, like, we have come up with this sort of a general approach of Matryoshka models. That is, we would want to put one model within the next model within next model. And this approach has sort of, we have tried it out in various ways. We have sort of, made sure that, like, as you sort of, put this approach to test on different axes, on different sort of, extreme angles, is it working or not? And what we found is invariably so far, like, that the approach has been holding along multiple axes. So I will not have time to talk about all the work that we have done in this space, but let me give a very high-level bit here. So the first line of work that we did was around Matryoshka embeddings or nested embeddings, where the idea was that when you are sort of creating embedding of data, let's say if I have a text document, I can create an embedding of that document, which then I can use to retrieve the document or sort of find nearest neighbors to the documents, etc. So it's a very, very common technique. Now, in earlier times, what used to happen was people would come and say that, okay, I will create an embedding which is 256 dimensional. Then somebody will say, no, this 256 dimensional embedding of the document is not enough for me. I need much smaller storage. So somebody will then have to design a new embedding model to create a 128 dimensional embedding. Somebody will need to then redesign maybe 64 dimensional embedding. So you had to redesign the same kind of architecture for multiple use cases. In Matryoshka embedding, what we were able to do was you train one single embedding model, but within that single embedding model, you can nest multiple dimensional embedding. So you can, within a 256 dimensional embedding, you can have a 128 dimensional embedding, you can have a 64 dimensional embedding, and so on. So you train once, you release your embeddings to your clientele, and then based on the requirements of each use case, people can pick and choose how they want to go about these embeddings, right? So this approach became fairly popular because of its generality. It did not care for what was the underlying architecture, what was the optimization function, what was the loss function, etc. It was a general technique. So it could be applied to pretty much any setting. And because of that, it has become fairly popular, where pretty much all the embedding models that are out there use this kind of nested structure. Last I checked on Hugging Face, Matryoshka embeddings kind of models were downloaded maybe more 15 million times every month, etc. So it has been fairly sort of standard approach now. The other then approach that we came building upon this idea of Matryoshka embeddings was that of matformers. That is, we want to now take our large language models and bring the same sort of nested structure within it. So there, what we did was, in matformers, we took one transformer architecture and we had this nested structure in the transformer architecture. I'll talk about matformers in a little bit more detail. Time permitting, I'll also talk about matquant, where the idea is to have similar nested structure, but in the quantization of model. Again, quantization becomes very, very important to make sure that the model can be served at very low cost, at low power, and in low latency regime. And finally, we have this nested routing kind of structure when we want to deal with very long context. Like if you have a long video, you want to understand what is going on in the video, we have this new approach of Monet that can do this nested model building to make sure that we can do this long context video understanding in much, much more cost-effective fashion. Let me quickly go over matformers. This is your standard transformer architecture. Venkat also displayed it. Let's just focus on feed-forward network for now, because that's where most of the cost and energy ends up going, unless you are looking at very long context inputs. So there, like this feed-forward network has basically this very simple structure of like a key value retrieval. That is, you get this token embedding, you look into this database of W vectors, and it tells you that okay, what all vectors might be important, which is then denoted by this activation, and then you basically take those activations and you combine them in some ways using this second matrix, and you get your next sort of token representation. So this sort of part ends up costing the most in terms of power, cost, etc. So our initial thought was, let's try to see if we can bring in the Matryoshka embedding structure within this feed-forward network. That is, can I sort of say that I have these various activations or neurons? I can sort of say that first 1/4 of the activations or neurons belong to my smallest model. And then the second set of activations, that is, let's say, these activations belong to my medium-sized model. These belong to my large-sized model, and this belong to my full Excel-sized model. So within one model, now I have nested my extra large, medium, and small-sized models, right? And now here we are using these exponential spaced granularities. That is, we are sort of saying that okay, if the largest model has say 16,000 activations, then the large size model should have say 8,000 activations, and then 4,000 and 2,000 activations, so that we are covering as wide a range as possible. Okay. And now we can take this matformer block, we can put them together to form our matformer model, right? And while this idea I'm explaining mainly around the feed-forward layer, but actually this idea can be applied on pretty much all axes of your model. So it can be applied to depth, it can be applied to attention, it could be applied to the token representation of the token. So it can be, it's a fairly general idea, and various follow-up works have also sort of taken it into various other regimes, like looking at it in the input regime, output regime, etc. And how do you then go and train it? So while I can define this architecture, but I should be able to train this architecture in an efficient manner, what we end up finding is that the most simple thing that we could have thought of works out fairly well. That is, if I take laws for each of these nested submodels, add it up in some weighted form, and create a joint training function, and then let's just go and optimize it. Of course, you can sort of optimize it in ways so that it doesn't end up costing you too much, because one option is that for every batch, you will do forward and backward pass with every single model, but you can come up with more intelligent techniques like picking some of the model, doing forward backward pass only with them in certain batches. So those details aside, the bottom line is that this can be trained in an efficient manner. And what we can now get is, in one single model, we have these multiple models nested, right? So that's good. So here, how many models will be nested? There'll be basically 3 models nested within this one large Excel-sized model. So this can ensure that as we are doing our adaptive inference, we can pick and choose whatever models we want. So let's say if I am deploying my model on a mobile phone, maybe I can pick a M-size model, and so on a mobile phone, I can pick my S-size model and deploy it there. But on a more powerful laptop with GPUs, powerful GPUs, I can put maybe an L-size model. So I can sort of pick and choose my models. So that's good. But the interesting part is that now I can do something called mix and match to not only generate these 3 or 4 nested models, but actually hundreds of nested models. So the idea behind mix and match is that within each layer, I can pick one of the granularity. So let's say the bottommost transformer layer has Excel-sized granularity, but the second layer has S-size granularity, and the third layer has maybe M-size granularity. So by doing that, you can actually pick hundreds or thousands, or in fact, millions of models. And now what you can do is you can sort of figure out that what model's performance is working best for your use case, for your power constraints, for your data constraints, right? So this is what we end up finding. So due to this flexibility, we released Matformer in Gemma 3N, which is the model that is powering Gemini, the on-device Gemini for Pixel 10 phones, various Samsung phones, and various other partners, Android partners. And the advantage of Matformer here is that we have a 2 billion parameter model sitting within the base 4 billion parameter model of Gemma, which means that in the same RAM, I have not just a 4 billion parameter model, but I have a 2 billion parameter model. In fact, I have many more. I have even a 3 billion parameter model, a 3.5 billion parameter model, etc. All these models are sitting there. And now, based on your application's requirement, like, if your application is relatively easy, like say Gboard, where you are just doing next word prediction, you can use 2 billion parameter model. But if your application is a lot more complicated, maybe you are using it for some sort of personal assistant, you would want to use full power of 4 billion parameter. And here what we demonstrate is that as you change the number of parameters, the accuracy of the model changes smoothly. That is, this is our 2 billion parameter model. This is our 4 billion parameter model. But these are the models that we just literally read off by doing this mix and match. So we did not have to do any additional training, no additional distillation, nothing. Just by reading it off, we were able to sort of generate this entire curve of cost versus accuracy, or number of parameters versus accuracy. All right, I have only 45 seconds remaining. So let me just give a very brief overview of the next line of work, that is, which is that of Matryoshka quantization. So idea here is like, even more simple. When, as Venkat said, that like, when you are doing decode, you are mainly memory bound. That is, most of the time, your GPU is sitting idle. All you are doing is you are taking your weights from your high bandwidth memory and transferring it to the SRAM on the device. Right? And so if you can cut down that cost, then your latency reduces significantly for your decode. Actually, it helps, like quantization helps prefill also, because you reduce the size of the model. And in prefill, you are very constrained on the total memory that is available to you. So it helps both, but mainly, let's say, decode. So Gemma 9, Gemma, let's say 2 models are like, say int 8 quantized. So it's a very sort of standard approach to make the models efficient. But now if I have this 8-bit quantization model, I can naturally sort of say that why not nest multiple models within it, right? That is, I can put a 4-bit quantized model and a 2-bit quantized model also. That is, what I can do is just take the first 2 bits here, and that becomes my 2-bit quantized model. And I can take first 4 bits here. I can create a 4-bit quantized model. So in some sense, quantization already has this Matryoshka structure embedded within it. Although the issue is that if you just create these 2-bit or 4-bit quantization models, because the models were not explicitly trained with this kind of loss, these kind of sort of quantization, it ends up hurting the quality significantly. So in Matryoshka quantization, what we end up doing is, so this is what this sliced thing shows. That is, if you just slice out your int 8 model, then the accuracy can decrease significantly. In Matryoshka quantization, what we do is we give a joint loss and directly optimize for that. And if you do that, then what we observe is that the model's accuracy becomes significantly better. In fact, compared to, say, training just a 2-bit quantized model, this Matryoshka quantization ends up giving you 3% lift, at least on some benchmark. So it ends up, in fact, helping you on your standard 2-bit quantization. But now the advantage is that you can create this series of models also, where the effective bit rate is not just 2 or 4 or 8. You can also get a 6-bit model. You can even get a 3-bit model, 2.5-bit model, like whatever effective rate you want. And by using some more sort of tricks, you are able to actually get this entire Pareto curve to look very good, like to look almost as good as the best you could have hoped for. So skipping over all this, so one of the key idea that came in handy to make this Pareto curve work is that of co-distillation. That is, when we are training, let's say, into quantized model, we are also distilling from the int 8 quantization that we are running live. So by doing this live co-distillation, we found that like the accuracy of the model can be improved significantly. Let me finish quickly. So basically, adaptivity and elasticity are really, really crucial components of AI models, because as we go towards like these single large giant models that are serving everything, we would want to make sure that there are ways of using them in the way that best fits our application. And this principle of sort of nested models or Matryoshka generalizes fairly well across multiple sort of modern blocks. And it is fairly easy to use, scalable. So I please go try it. Okay, thank you.
Thank you.
Thank you for a marvelous talk, Prateek. Time for a few questions.
Hello.
Yeah, maybe you can.
Hello. Myself, Yash, I'm a project associate in IISc. So you talked about these nested models and all. Like when we are into the application side of this, I just wanted to know like how is the trade-off between the training or inference time when we are doing the nested model training for the 4 billion parameter one and the one which is just a model with 4 billion. So
Okay.
how is the inference time trade-off?
Yeah, so training time, you have to pay cost somewhat less than what you would have paid for training a standalone 4 billion parameter model and a 2 billion parameter model. But now you're getting a 3 billion parameter model for free, a 3.5 billion parameter model for free and all. So you are getting the series of model for free by paying cost of training two models. So that's on the training side. On the inference side, it depends on your setup. You should be able to pay the cost of whatever inference size model you want to pick. So let's say if you are picking a 3 billion parameter model, if you are optimizing your system well, you should be able to pay price for that only. But if you're not careful, then yeah, like, it might be hard to sort of utilize that.
Okay, and when we talk about the training side, like you said about different models. So for the 4 billion, like, do you have any exact thing, like how much does it take? Any, like,
So roughly 4 billion, let's say, would be, I'm just giving rough estimates, will be about, say, 2 times more expensive than 2 billion. So what you are doing is you are paying 50% more cost of training one single 4 billion parameter model, but you are getting all these models for free.
Thank you.
Please go ahead.
Hello, I am Kalash Kala and I am also a project associate at IISc. So my question was that, like, so in all the math variations like math embedding, math transformers and all, so like is your approach like you use like math embeddings to create those fundamental like blocks like 2 billion, 4 billion, those parameters, or for each and every implementation you have something like you find something fundamental and then try to make subsets out of it? I hope like.
So in some sense, yeah, like, what you would want is, like, this technique is useful only if almost out of box people can use it in adaptive fashion. Because if you have to do a lot of work to extract out the the smaller subpart, then it's not really worth it. So that's how we picked up a thing. So like say if it is just embedding, then like the simplest thing to slice is embedding dimension. Same with say transformer architecture. Like the simplest thing to slice was FFN layer. The attention heads and all also can be done. So yeah, like we try to sort of focus on the simplicity, that okay, what is the simplest thing that I can just slice off, and that reflects well also on the model capacity as well as on simplicity of using it, and that's what we went after.
Okay, thank you.
One more question.
Hi, I'm Saurabh from FSID. Thanks for the talk. Your work on Matryoshka embeddings suggests that a vast majority of these semantic signals can be compressed into these initial dimensions, right? So it's like a two-part question. So how much headroom do you think we still have with us? How much does your gut say that we can compress it down even more and see these model sizes reduce in the coming years? And also, if these over-parameterization is still a necessary cost that we have to pay for these emergent capabilities to emerge out of these models.
Okay.
Can we do AI for? Can we see these scientific discoveries happening with these small compressed models, or we still need these emergent capabilities from the large models?
So the second is probably like much bigger discussion, but let me first at least address the first part, which is that you're right that what was somewhat surprising was that somehow the structure seems to be, at least like along the axis that we explored, structures seem to be sort of, present in a very modular fashion. That is, if I look at the embeddings, the first 16 embeddings would capture a rough resolution of the world. That is, they were able to differentiate between, like if I'm talking, let's say, image embedding, then they were able to differentiate between birds and humans, right? But now, if I want to go further, down and understand like the difference between different birds, that's when I would want to go from 16 to 32 dimension. And then if I need need to go even further, like, differentiate these like species, I will need to go from 32 to 64. So somehow this very nicely, like, in a modular structure, the information seems to be organized in these networks and in these embeddings, which was a revelation. And that's what we found also with, say, the Matformer work. In terms of how much more compressibility is there, like, that's a somewhat tricky question, because a lot of components have to come together there. General gut feel is, like, that we are, like, already pushing things very close to the amount of information we want to pack within these models. But yeah, like, maybe new research ideas can unlock it. As for whether you do need really large models to unlock these emergent abilities, that, I mean, so far, whatever, like, proof points we have, it does feel like you do need very large models, but that large can be quantified in a variety of ways, right? So large could be the amount of computation you have to do. Large can be the number of parameters you need. Large might be the amount of inference time, sort of, flops you need to spend, like the number of thinking tokens you need to spend. So so there are multiple axes on which you can sort of go explore this large. And I don't know what would be the correct, like, whether if I just scale number of parameters, but keep the amount of compute that I do to be very small by making these parameters sparse, would that be enough? I don't know. So it's a very sort of fascinating question. But one thing that I would definitely encourage is to just think about the large computation or large sort of part from sort of multiple axes.
Thank you. Thank you, Pratik.
Thank you.
Beautiful talk.
Okay, thank you so much.
On elasticity and also adaptability of the models. Thank you.
Thank you so much. Thank you. Thanks. Give it back. Thank you.
Our next speaker is Professor Prashanta Kumar Ghosh. He is on the Faculty of Electrical Engineering Department at the Indian Institute of Science. He is a very accomplished researcher in speech signal processing. And his work is mostly focused on human-centered signal processing, including speech signal processing, with application to education and healthcare sectors. He has done a lot of influential work in these areas. One of the most recent examples of his influential work can be seen in the Vani project. So today he's going to talk to us about the Vani project, which is a project on multimodal, creating a multimodal data set for Indian languages. Over to Prashanta.
Thank you, sir. Okay. Thank you, Professor Narari, for the nice introduction. Thank you, Professor Chiru and the organizing committee to invite me here. So for next few minutes, I'm going to talk about the journey of Vani over the last 3 years. It's a project through which we wanted to capture the multimodal way of capturing this Indian language landscape. So I'll talk about why, what, and how about Vani. So let me begin with why. This is a cartoon way of capturing why we wanted to do Vani. Think of a lady from a remote village in India trying to seek help of a service through her voice because she can't type. As you know, many of us use the voice feature of WhatsApp, even don't type, right? Some of them cannot even type. And she finds it difficult because the AI behind the service cannot recognize her voice. And so if we fail to cover users like her, we fail to cover a majority of the Indian population, and mostly from rural areas. So the idea was, how do we really spread the solutions, AI solutions today, particularly on voice, to these people and population. And also we know that India is not about one language, Majority of the Indians can't speak English, and often they speak multiple languages. How we solve all this problem is where Vani began. Just to give you an idea about some of the applications that are voice-enabled that exist today, some of them are here on the screen. And the biggest challenge that many of them are not that widespread and successful is that India has multiple languages, of course, official languages or scheduled languages. There are more non-scheduled. There are more dialects and accents across all those languages. And how do you build solutions that cover all of them becomes a daunting task. So if you look at how these models are built, data is the gold for all of these models. And models build ornaments, as I say. So what data exists today? Of course, there is a constant effort of building the data. I'm talking about the voice data sets. But as you also may be aware of, that it's predominantly English. And that makes it challenging to cater to some of the services that I just mentioned in the beginning. So if you look at the data sets in Indian languages, in this bubble manner, without Vani, this is how it looks. And we wanted to make a big impact on this landscape. So one of the reasons that we felt when we started 3 years back, the limitations of the existing approaches was that they were language-centric approach. By that I mean, when we collect data, we go to an individual and ask him or her to speak, ask them to speak in Hindi or speak in Telugu or speak in Marathi, right? But often we did not realize that they may not be speaking the Marathi we wanted them to speak. They may be speaking something else. And that's what we wanted to discover through Vani. So this saying, as you see on the top of the screen, which says "Kos kos par badle pani, tyar kos par vani," it just tells us that languages in India are not discrete. They are like colors, changing slowly from one to another over the geography of the country. And we wanted to really quantify it, discretize it, this continuous function. It was a challenge. So what we realized that in India, if you look at geographically, there are 773 districts, right? And how do we cover the entire country was a challenge, and we had to take a call. I'm just going to come to that. So the philosophy of Vani, based on these learnings, was that we are going to go not in a language-anchored manner. Rather, we're going to go in a district-anchored manner. So it means we go to a district and sample population, some speakers, and ask them, what language do you speak at home? In fact, this label comes quite wrong. Somebody thinks that they speak Hindi, or he or she speaks Hindi, but actually they're speaking Bhojpuri. So that becomes illegal, but it also helps us discover languages which are even not captured in the latest census. So that's first one. And because it's continuous, it helped us to capture this slight variation in languages. So the vision of Vani is to create this language, dialect-rich corpus, build solutions on top of it to discover whether the existing tools, solutions already are good or they need still improvement. And of course, when we build these tools, we do the empowering of stakeholders and democratize AI for all these Indian languages. So let me move on. And let me tell you why we wanted to take this approach. So in Vani, what we do, we present an image to a speaker and ask that speaker to talk about that image. So this helps us to solve many problems. Number one, the speaker need not be literate. Number two, the image that are captured, they are local, that from that district. So that naturally captured the diversity and culturally, unbiased way of representing the Indian continent. And third, it increases the vocabularies because as we see many, many images, it also brings a lot of associated words as these people speak. Right? And people also found it very comfortable to talk about an image at their home in isolation, not being confronted by by another speaker, and they may feel shy to speak. So traditional approaches often use rate speech or conversational speech, but we chose image prompting for all those reasons. So as of today, we are at the end of phase 2 of Vani. We have now open sourced 31,000 hours plus speech from 156,000 speakers from 165 districts, having a coverage of 109 languages, speaker declared. Out of those, 2,000 plus hours transcribed. So that's where we stand today, and we'd like to take it forward. So this is a visual way of presenting all the statistics. I'll not repeat that. Let me move on to the core part of it. So here are some samples. Maybe I'll not go into playing for now, but this just represent, if you go to Vani webpage, we do present a way where you can go to a district, go to a sample a speaker, an image, and can listen to that person's voice. It truly represent this language diversity. So there is a complex process behind this outcome, and this slide captures that in brief. So one is a multimodal data. It has images, it has audio recordings, it has transcription, right? For each of them, we had to follow a very detailed set of steps to make sure the outcome is of high quality. Still, we have challenges. So for image, it's captured by the local district people. We have to make sure that images are proper. It should not contain PII, which is called personal identifiable information, right? And it also has diversity. Then for the audio, we get the recordings, and it goes through multiple levels of automatic, semi-automatic, and manual checks before it is released in public. And same for transcription. A person types out by listening what he or she hears, and it goes through a total of 3 validation stages to make sure that the outcome, what is typed, is actually correct. And I'll come to some learnings that happened because of that. So in this journey, we also collect from every speaker a very rich metadata, starting from not just their gender and age, but also their socioeconomic status, to understand the correlation between what kind of background they are from, what is their status, and the speech, if there is any, and many others. So here are some samples. So for example, if you look at this map, it shows per district how many speakers PIN code we could record from. As you can see, there are some districts which are very difficult to sample, while some others are more dense. So we could get many more varieties. You may also see that it is Hindi predominant. So it means it's speaker declared language, and they think they're speaking Hindi. Now let me tell you the challenges and learnings that we had. So begin with challenges. So the very first thing we found is the geographical barrier. There are some cases where it was difficult even to reach to those places. But when I say reach, it means we have to reach to the speaker. We need to reach to the experts in those regions, right? And just sheer way, the way the location is not reachable by transport, or even because of due to lack of internet, and so on and so forth, it's become very, very difficult in some of the districts. Then the next was getting skilled people. You may probably feel that recording speech, writing it down what somebody is speaking, may be a very trivial task. Actually, the more and more I do this, I realize that it is a super duper skilled task. And I'm coming to the transcription part in a bit. So getting skilled people was quite difficult because it requires training. And the training can only happen if you have a person who can get trained quickly and then do as you want. Next, particularly, was getting linguists and experts in rare languages, which was very difficult. And we had to take several calls after a lot of struggle and getting some of the experts in those languages. Another challenge was many of our automated systems were dependent on existing tools, NASR models, automatic speech recognition models, and then they don't do well. And we had difficulty in processing, checking the quality of those recordings in those languages. Again, another challenge where languages did not have script. We had to decide which is the closest script to borrow from, which language script to borrow from, right? And those are some of the calls we had to take live as we did the project. Of course, there's a financial aspect because, as you can imagine, through this project, thousands of people got employed. And of course, they look this as an opportunity. It's a financial opportunity for them. And it's a financial engagement also. So how do you really run this machine over the years is a challenge. Let me tell you some of the learnings, and that's the one I was mentioning a couple of times, which is the top left, about high WER difficulty. So WER stands for word error rate. So if you get a recording and give it to two individuals from the same district where the recording was done, we realize that those two people's transcription, or what they type, do not match. And they don't match because of many, many reasons. And when you calculate how different they are through something called word error rate, how many words do not match, we realize that that rarely go beyond 10%. So there is an inherent disagreement between multiple transcribers as we get it done, even through the native person of the respective districts. And what we realize also is that if you give that to a regular transcriber of that language, then it goes even more than that, 30–40% WER. So let me give you one example. If you take Telugu as a language, we have found 4 major variants. One is Guntur Krishna, another is Visakhapatnam area, another is Anandpur Chittur, another is Nalgonda Karimnagar. They're all speaking Telugu, but it turns out that a person who is from Nalgonda cannot even understand. They realize that somebody speaking in that recording from Krishna, but they can't even type what they're speaking. Now I'm talking about not even that. I'm talking about getting 2 transcribers from Nalgonda itself. They don't agree with each other. And this is an inherent problem. I think it just tells us the underlying modeling, the way we have to model speech recognition and how to evaluate it. I think this brings us those critical questions. I'll move on. There are a bunch of learning. For the sake of time, I'll not go into the details. But I must mention that some of the languages that we discovered and the recordings and their transcriptions, they are not present even in census. So this is a nice return for all of us. So here is the link where the Vani data is hosted. So you're all welcome to download, use, and give feedback. What this slide shows is the current statistics of download. There are a large number of applications, Vani being multimodal data. I'm not going to those details. Many of you are experts here in many of those. Just going forward, what we'd like to see Vani supporting the startup ecosystem, helping to do better and impactful research, and expanding the community. So let me move on and tell you 1 and 2 experiments if possible. So what we did, just to see how good is this or useful is the Vani data, we took what is called a whisper small ASR. So as you see here, and we took many, many open-sourced test sets which are in the x-axis. So we ran the whisper small as is on those test sets from open-source data sets, and those are in blue colors. Now, then we use Vani data to fine-tune whisper small, and that reduces that fine-tuned model on all the corpora that are out there in the market. This is for Hindi, but it's not for Hindi alone. Kannada and many other languages this trend is observed. So that shows that Vani data indeed brings complementarity to what exists today. I'll skip the next slide. I see that the time is up. Just 1 minute. We have seen also several startups have found the one data useful. They are using in their systems and getting better performance. So in a sense, this data, Vani database, is what India is speaking. We are going to individuals across the country and collecting in the language they speak at home. So we all need to come together, right? Not just our Vani team, but I invite everybody to come, contribute, give your ideas, use the data, give feedback to make the AI, inclusive for digital India. With that note, I'll stop. Thank you.
We have time for a few questions.
Yeah. So any work done on Kannada language? Because Kannada is totally different in Bangalore, Mysore, Mangalore and Hubli, Karnataka.
Yes, yes.
Any work is done on that?
Yes. So for Kannada, we have, I don't remember exactly the number of districts, but we certainly cover the 5 variants of Kannada. For example, the Dharwad Kannada, the Mysore Kannada, the Bellary Kannada, of course, the standard Bangalore Kannada and North Karnataka Kannada. And we pretty much do that not by even this name, but we just go to the individuals in those districts and record the way they speak.
Any other question?
So I have a quick question. We have a SaaS platform for quality assessment of agriculture crops. We have built a bot where farmers can ask questions based on images and there are interactions goes on. But of course, we have opened up for 7 languages already. We have worked in 7 different states. So my question comes, is there any APIs open through Vani to which we can integrate into our systems?
We have put out models in Hugging Face, but we have not put them as an API at this point. So you are free to use the models that are up there in the Hugging Face.
You had a question?
Namaskar, my name is Raghuram from Chemical Engineering.
I think you have to turn on the mic, please.
I have a different question. May not be related to this, but partly related. See, we are seeing so many archaeology stones and all. There are different types of Sanskrit text and all embedded. Generally, we have one thing, text to speech, speech to text. Whether these models will help those things to decipher what is written 100 years back, 200 years back, 300 years back. Archaeology department, stones.
So this is from the script on the stone. So this database is primarily for interfacing speech with image or text, right? So it does not directly solve the problem that you are saying, and those languages may be even different from what we have today. So I'm not sure at this moment that whether it can directly help, but I need to think and come back. I see. I see.
Deciphering those texts, but still it's a difficult task. So this AI technology, from text to speech, speech to text, can be tried. That's what I want to tell you.
Sure. I mean, I'd like to know more and come back to you, sir. Thank you.
So thank you, Prashanta, for telling us about this wonderful nation scale project. We would like to hear more about it. I'm sure we'll hear more about it in the years to come. Thank you very much for a very nice talk.
Thank you. Thank you, sir. Thank you. Thank you, sir.
So I will not take too much time as session chair. All of you will agree with me that we had an extraordinary session, a memorable session. No, I will not stop so soon. I think the session was on tackling data and compute challenges in building efficient, scalable, and high-impact AI systems. I think for me, the highlight from the session was, we got so many extraordinary creative ideas and extremely innovative sort of ways of achieving efficiency, efficacy, elasticity, adaptability, and so on. And I think all the talks told us how, all of these will enable us to advance the research and practice of resilient AI systems. We must really thank for all their wonderful talks. All the four speakers, Dr. Chris Gopalakrishnan, Dr. Venkat Padmanabhan, Dr. Pratik Jain, and Professor Prashanta Ghosh. Let's put up a big hand for all these excellent talks today. And we now break for lunch, and the next session starts exactly at 2 p.m. here. Thank you very much, and thank you very much for all the nice questions also. I think that concludes this particular session. Thank you.
The audience can head to the third floor for lunch. The speakers and invitees, lunch is arranged in the left side of the auditorium. The auditorium's left side. Please be back at 2 p.m. for the next session. Yeah. Can everybody please come in? The session is going to start.
Check, check, check. Mic testing, check. Check.
Please be seated. We begin our session 2, Challenges and Strategies in AI Research and Impact Pathways. Professor Navkan Bhatt, Dean, Division of Interdisciplinary Sciences, Professor at Center of Nanoscience and Engineering at IISc, and alumni from IIT Bombay and the Stanford University. Professor has paid major initiative at IISc in nanoelectronics, which eventually led to the creation of Center for Nanoscience and Engineering at IISc. Professor was instrumental in creating the National Nanofabrication Center, benchmark against the best university facilities in the world. He has led the National Nano Users Program, which trained more than 4,000 researchers from across the country with numerous contributions to the field. He is a fellow of the Indian National Science Academy, National Academy of Sciences, IEEE, and many more. He is a recipient of Infosys Prize for Engineering and Computer Science, Bharat Innovator Award, Dr. Abdul Kalam Technology Innovation National Fellowship, and the awards go on. Professor is also the chair, Vision Group of Nanotechnology, Government of India. I invite our session chair, Professor Navkan Bhatt, on stage.
very good afternoon to all of you. It's indeed my pleasure to chair this session. Actually, this session will be co-chaired by me and Professor Narahari. He is somewhere around. This is indeed a great pleasure for me to introduce the first speaker, Dr. Devi Shetty. This conference is about AI, scale and resilience, and we don't have a better person who personifies that, in terms of the scale and lives that he has touched. He needs no introduction, but formality. Dr. Devi Prasad Shetty, born in 1953, is an Indian cardiac surgeon who is the chair and founder of Narayana Health, a chain of 24 medical centers in India. He has performed more than 100,000 heart operations. In 2004, he was awarded Padma Shri, the fourth highest civilian award, followed by Padma Bhushan in 2012, the third highest civilian award by the Government of India, for his contribution to the field of affordable healthcare. Without much ado, over to you, Dr. Devi Shetty.
Thank you so much. Yeah, I'm okay. Can I have the first slide? Okay. Thank you so much for the opportunity. If there is one industry which will get completely disrupted beyond recognition with the AI, is going to be healthcare industry. In the next few minutes, I'm going to talk about what AI can do in healthcare, not about a hypothesis, something happening in US or Europe, something happening right inside my hospital. We started an AI division around 9 years ago. And most people started talking about AI only after ChatGPT. And we were using AI for many aspects of healthcare, at least more than 5 to 6 years. I believe that India will become the first country in the world to dissociate healthcare from wealth. India will prove to the world that the wealth of the nation or wealth of the family has nothing to do with the quality of healthcare its citizens will enjoy. And many of you may think, yeah, it's going to happen, but it may happen after 30 years or 100 years. It's going to happen in the next 5 to 7 years. Because most of the foundation for this massive transformation is already available. It is just there, and someone has to put all the pieces together, and that is happening very fast. I'll just give you one example of how we use AI. This slide, what you're seeing, is the blood gas report. It is one of the tests which is commonly performed in the ICU to check the status of the patient. And a report comes with about 20, 25 different data points. ICU has many people working, but very, very few handful of doctors and nurses can decipher the data, then plan the treatment. And just below the blood gas report, you can see the AI interpretation of the blood gas report. And also, it not only interprets, it also advises the doctors and nurses what to do. Now, before this pilot started, very few nurses knew how to interpret blood gases. Just 1 month after we started, virtually all the nurses in the ICU have become experts in interpreting and taking action on the blood gas reports. This is the power of AI. It is not only smart, it makes everyone using it very, very smart. This is one example. The next example is, this is called a risk score. A patient after the heart operation stays in the ICU for 24 hours or few days, and there are multiple data points which will either go towards improvement or deterioration. And these are all very subtle signs and symptoms. And it is very difficult for a doctor to make any sense looking at one or two signs and one or two signals. Our AI tool interprets about 70 odd data points, and 6 hours to 10 hours before the final cardiac arrest, all these data points will keep moving up and down. So you can actually predict a so-called sudden cardiac arrest at least 5 to 10 hours before the event. This is the beauty of all these technology tools. So what is the advantage? All over the world, there is shortage of intensivists. India is no exception. If an intensivist is working inside the hospital, then they work for 8-hour shift. The best ICU care patient gets between 9 o'clock in the morning and 5 o'clock in the evening. After 5 o'clock till next day morning 9 o'clock, patients are managed by relatively junior nurses and relatively junior intensivists. And if you look at the safety, patient is the safest between 9 to 5. That shouldn't happen, that should change. How do you change it? We tell the intensivist that at night you don't need to be in the hospital. You can be anywhere you want. But 4 hours of the 16-hour cycle, you take the on-call, and in their laptop, they can see every patient, all the events happening. They can interact with the nurses and the doctors who are based there. And the moment the risk score starts going up, they will know what exactly has changed, and they will, the software itself will suggest what needs to be done, but ultimately it's a doctor who has to take the final decision. And when this transformation happens in a large scale, hospital will become safer for the patients. Why everyone thinks that the hospitals are the safe places for the patients? Unfortunately, it is not. Let's look at some of the safest hospitals on the planet in US. If 200 patients spend 24 hours in a hospital, 1 in 200 dies due to medical error, not medical negligence. And according to Joint Commission of US, the commonest cause of medical error, 67%, is due to communication failure. That is, something is happening, but the decision-making people don't get that information the way it should be. And all these tools will help the doctors to take the action well before the final cardiac arrest happens. This is the power of AI tools, which will empower the doctors. It will make the doctors safer for the patients. So essentially, in a matter of time, you will have intensive care units without intensivists. They will all be working from remotely, and they cover only for 4 hours or 5 hours at night, but take in rotation. So every doctor, whenever he is taking care of the patient, he is fresh after a sleep or before the sleep. One of the nightmare for a hospital is discharging the patient in the morning. When your occupancy is about 80%, there is no bed available. Morning, you have to admit at least 60 patients, and they come there, and you need to discharge 60 patients. Before we implemented AI, it used to take us over 5 hours to discharge a patient. If you have ever admitted one of your patients in the hospital, you know the problem of discharging a patient. And The biggest problem is creating the medical record and creating a discharge summary. We had 30 girls running around like headless chickens early morning, trying to discharge patients on time. And now our AI tool in our ADI, which is the tool we have as a EMR, you have to just tap one button, say discharge the patient. Entire discharge summary gets generated. It comes like this. It is auto-populated. And a doctor who is on his way to the hospital, sitting in his car, he can check all the data and advise for discharge or make any changes. Entire process can be done within 5 to 10 minutes. So it is not a transformation of efficiency. It is a different experience altogether. In a heart hospital, there are not more than 30 different types of operations we do. It's the same operation, we keep doing it. And what is different with each patient is the complexity or so-called findings. So when the doctor finishes the operations, cardiac surgery, straight away after a few minutes, he has to go to another operation theater. And one of the hardest things for a hospital administrator is to get the doctors to write the operation notes. And normally it takes about at least 15 to 20 minutes to complete one operation notes. And when they skip from one OT to the other, they forget the major finding in the previous patient, and you may not get a very accurate operation notes. Now what they do, when they finish the surgery, all they have to do is to find what is different in this patient. They only talk to the AI what is different, and everything else is standard. And within 3 to 4 minutes, the AI will generate the operation notes. He can correct it in his own phone, and it will be entered into the system. One of the biggest change we made in electronic medical records is that we decided to build the entire electronic medical records on a mobile phone with the mobile first concept. Whereas all over the world, EMRs are developed for the desktop. Why we made the change? Because doctors look at the laptop or a desktop 5 to 6 times in a day. But they look at the mobile phone 200 times in a day. So if you want their attention, create the EMR for the mobile phone. This is what we did. And that's what brought in significant efficiency. All over the world, when a doctor is doing the echocardiogram or an ultrasound, there are scribes sitting next to them. And typically, doctor does the echo, and they keep dictating. When he starts dictating, patient will think that he's talking to him, so he will try to respond. Then as they are doing the echo, in a random fashion, they can keep dictating. In 5 minutes or 10 minutes or 15 minutes, when they finish the echo, all they have to do is to tap the enter button. Entire echo report gets generated and it comes in this format. Then they can correct it if there is a mistake, and they finally say it's enter. It will go to the system, and the report will appear in the patient's mobile phone before they can put on their shirt after the echocardiogram. This experience is nothing short of magic. So these are the experiences which makes entire consumer experience. We don't call the patient as a patient. We call them as a consumer, because the experience of the patient should be like a consumer who goes for consuming some services. So the consumer experience will be dramatically different. We are in the process of building about 4 or 5 hospitals, which will be commissioned in the next 5 months to maybe 1 year. And all those hospitals will have people in the scrubs only working inside the building. People who are not going to touch the patients, people who are not wearing the scrubs, they don't need to work in the hospital. They can work remotely and support the hospital. So they can support multiple hospitals than one hospital. So that will dramatically decongest the hospital and brings in huge efficiency. So when you enter our hospitals across the country, you will find the reception without the receptionist. There are kiosks everywhere, and believe me, we think that the patients are not tech savvy. But with our experience, we have noticed they are much, much smarter than we are. They can, in no time, they learned how to use the kiosk. And today, a lot of them do the registration and pay the money in their own mobile phone. They don't even go to the kiosk. When we first introduced this mobile registration with our app, they could register, they could pay the money. And one particular patient told one of our doctors that, "Sir, I have paid the registration fees, but your secretary hasn't deposited the money." And the doctor asked him, "How do you know he hasn't deposited?" Then he opened the NHCare app and showed the doctor that it is not entered. The payment is still pending, whereas I have paid the money. And we realized that he's right. The secretary pocketed the money, and he could pick it up when we missed it. So essentially, our assumption that this technology is not suitable for our rural India, it is not true, because most of our customers come from rural background. So one of the apprehension everyone has in healthcare is that whether AI will replace the doctors. This is the statement by Dr. Curtis Langlotz from Stanford. AI won't replace the radiologist. He's a radiologist himself. He said AI won't replace the radiologist, but the radiologist who uses AI will replace those who don't. So there is no threat for anyone that they are going to lose the job in healthcare. It is just that the way they function will be different. And in the end, all these technologies will make healthcare safer for the patient. Now, we believe when I talk about dramatic transformation in healthcare, this happens because of massive digital adoption. I just want to give you the example of world's largest taxi company called Uber has no vehicles. Facebook doesn't create contents. Alibaba has no inventory. Airbnb doesn't own the hospital. Airbnb doesn't own the hotel rooms. The world's largest healthcare provider will have no beds. It is going to be a software. And this is going to be the future. So we made over $100 million of investment in building this digital platform. Our idea is that this should be available. 80% of the hospitals across the world do not have electronic medical records. They can't afford it. We want all those hospitals to have an EMR. If they can't afford the expensive one, they can have our EMR. And they can pay what they can afford to pay. If they can't afford to pay, they can have it free of cost. In Bangalore, Sai Baba's hospital, and in Tamil Nadu, few charitable hospitals, they all are using our AI tool with great efficiency. Now, about a few months ago, one of the CEOs of a charitable hospital in Tamil Nadu, who had our tool for more than a year, he was very happy with the outcome. He came to thank me, and he asked me an interesting question on why we gave him the EMR free of cost. I just smiled and I asked him a very interesting question. I asked him, by giving him my EMR free of cost, have I become poorer? No. Then I asked him another question. If I didn't give him the EMR free of cost, will I become wealthier? No. This is the power of converting atoms into bytes. Everything what we look today will change once atom gets converted into bytes. This is the beauty of an amazing country called India, which will transform everything about delivering healthcare. Thank you so much for the opportunity.
We have time for a few questions. If you have any questions, please raise your hand. Yeah, Gopi.
Yeah. I remember reading an article in Economist some time back that you are competitive in terms of cost, and also you had better outcomes than Cleveland Institute, I believe, right? And I want to know if AI has actually altered this picture in any significant manner. Thank you.
No, that was the study. We are a case study at the Harvard Business School, which was, I think, done about 20 years ago, well before AI. They compared our outcome with some of the US hospitals. We didn't make the claim. Yeah. Sorry? No, at that time we didn't have any AI.
The
Yeah.
question is whether things have changed with the advent of
Oh,
AI.
yes. I can tell you that in terms of efficiency, in terms of safety, we are just getting there. But within the next 1 or 2 years' time, you will notice that the hospital will become much safer places for the patient. It is having a tool like what I have shown, the risk score. It is like a very experienced intensivist sitting on the bedside 24 hours, constantly telling the doctors and nurses what is going on with the patient and what to do. That is unimaginable, because in real world, you cannot have senior doctors spending so much of time with one patient. ICU generally has 30, 60 patients. So the AI will give you the indication for an impending cardiac arrest 6 hours, 10 hours before the actual event happens, because it can see the. I'll give you one example. Our team has developed a AI tool. You show the ECG, you show the photograph of a ECG. They will tell you whether that patient has a coronary artery blockages with the 93% accuracy. 93%. And this is humanly not possible, because ECG is not meant to detect coronary artery disease. It is meant to see whether there is any changes in the electrical activity. But AI, because it has access to about 16% of the heart surgery done in India is done by us. We have that much of data for the last 25 years. So these tools learn from all this vast amount of data, and it's going to be a different experience altogether. Now they are working at detecting congenital heart disease with the ECG. Then they will develop the AI for detecting rheumatic heart disease with the ECG. And these things will dramatically change early detection of any disease. This is only in heart I am talking about. The similar thing is happening in other areas.
Yeah, I'm Venkat Padmanabhan. I lead Microsoft Research here. So thank you for the wonderful talk. In fact, we work with Narayana Health on some projects. So one thing I've heard is that traditionally in healthcare and education, there are two domains where technology has not really helped us much. That's why the inflation, I mean, the cost has been rising faster than inflation for these two. Do you see, first of all, do you agree with that? And secondly, do you see AI shifting that significantly, right? Where, costs might actually come down because you're able to automate and use technology.
I want to reproduce the statement by Mark Andreessen, who said that the software will eat the world. So according to him, every industry, every sector is a software sector, a software industry. And why healthcare is the most vulnerable industry is because there are only two things we do in healthcare. That is the decision and execution. Decision in healthcare is made by hundreds of data points. No doctor can decipher that many data like AI tool. And execution, no doctor can have his own style of execution. It's all standardized. If I diagnose a disease, I can't treat the patient the way I want. I have to follow the protocol. So if the decision is made by the AI, see, let me be very honest, today, some of the AI tools can make much smarter diagnosis than us. It is a matter of time before it will become legally mandatory for every doctor to take a second opinion from the AI before starting the treatment. It's going to happen.
Thank you.
I'm Shalab from Center of Data for Public Good. Two small things. So one is, I mean, when AI is making critical decisions, of course, you have a human in the loop right now, but explainability
Human
becomes
will always be there.
Okay.
Yeah.
So,
yeah.
okay, I mean, then explainability, I guess, is not something that you're focusing on in the research from a research perspective.
Sure.
Okay. Second thing is, so this human AI interaction. So there have been reports, for example, of the cognitive decline on humans because of use of ChatGPT, right?
Yes.
If the same thing were to happen to doctors when AI becomes more, percolates the medical system more, I mean, that would not be an acceptable thing for doctors.
Yes.
How do you prevent that going forward?
See, the first thing is AI will become better and better, and doctors' knowledge will also keep getting better. Like I gave you the example of how nurses who couldn't interpret a blood gas report, in a matter of 1 month, they could confidently interpret the blood gas report. So over a period of time, I believe that we also will grow with the AI. It won't our brain won't become defunct. Yeah.
Yeah. Hi, I'm Himanshi. I'm a health tech AI enthusiast. I have a bunch of curiosities about when it comes to AI, specifically in such a crucial matter like surgeries and doctors. So I'm trying to understand, like, let's say in private hospitals, this AI is only with the access, like only has the access to doctors, or do patients also get to actually understand how the diagnosis is being held through this AI, maybe making things more transparent? So this whole medical scam that is happening in India, through which the patient is rather more scared that the doctor is going to exaggerate my problem, make it into a big surgery when it's actually maybe simple, small problem. So does it actually also help the patient side?
Definitely. Nothing like having an informed patient who has hundreds of questions. Yes, yes.
Also, I would like to understand, so when it comes to AI, we have a lot of times problem with their accuracy rates and things going a bit sideways. So let's say the doctor has a very good gut about what the disease could be. So a similar situation has happened in my family where my uncle had ALS, but the doctor, it was only a doctor gut and all the symptoms were suggesting otherwise, and that is the reason we got very late for the treatment. So in such situations, let's say the AI is suggesting something sideways, but the doctor has an internal gut. What do you think the AI is helping or?
Yeah, for the AI to be effective, that requires a lot of data points.
Exactly.
If that doesn't come up with a proper hint on what's happening, that means it didn't get the data points. So once you have that many data points, unlikely that AI, I mean, it can make mistakes, but believe me, the doctor's intuition is very, very powerful, maybe to some extent more powerful than the doctor's. It's not that just doctor is going to disappear, he's going to be there, right? We are just using the tool to make us more efficient. Yeah.
In the interest of time, maybe we'll allow 2 more questions, so please do not come to the mic anymore.
Yeah, I just want to, no, she asked me about the robotics surgery. The robotics are run predominantly by the AI. Just want to show you, like, I always took great pride in my ability to anticipate how things are going to be in healthcare in the years to come. And whatever is happening today in healthcare is beyond my any stretch of imagination. I'll give you one example of how robotic surgery will transform surgery. one second. I'll just show you the, yeah. This is the photograph, I'm sure you can't see, of a 66-year-old man who his profession is climbing coconut trees. He had a bypass grafting with the robotic surgery, and you can see a scar below his nipple, one small scar. So when we do bypass with robot, we don't open the chest. We just make a small cut in the muscle and put the camera and the instruments and do the surgery. And he was discharged. 40 days after the surgery, his son sends me a video. One second. His son sends me a video of him climbing the coconut tree 60 days after the bypass grafting. With any stretch of imagination, I never thought a 66-year-old man, 40 days after the surgery, will be able to climb a coconut tree. This is the power of robotic surgery. And I'm more pleased because the surgeons who do the cardiac surgery using robot are all trained by us in India.
So I suggest both of you can be very quick. You can ask the question one after the other. Maybe you can give a combined answer.
Sure.
Yeah,
Sure. Thank you. My name is Santosh. I'm a tech entrepreneur. India has always been up there when it comes to technology, and when it comes to new things, we are always playing a catch-up game with the Western world. So my question is, when it comes to medicine and AI, are we on par with what's happening in the world? If not, like how behind are we?
Yeah, Sunil Sherlekar from Sankhya Sutra Labs. My question was about using AI for diagnosis. A lot of talk is going on about that. My worry is that AI can make mistakes, in which case, say, I am trying to figure out whether somebody has cancer. If the AI says he doesn't and he has, then there's a problem. If it says he has and he doesn't, then also there's a problem. So in which case the doctor has to look at all of the reports. So what does AI give you?
See, currently the AI is not used for the final diagnosis. It is used as a prompt. So we haven't reached the level to allow the AI to take a decision. When I say it reports the blood gas reports, it's not that we blindly follow the instruction. There is in red letter underneath, I couldn't show that it is a AI generated report, please reconfirm, right? So it is at that stage. But adoption of AI will dramatically, it will grow exponentially once the hospitals have the EMR. And adoption will be the greatest, it will happen at the greatest speed in India compared to all other countries, because we are blessed in having phenomenally skilled, knowledgeable, brightest software engineers. You give them a problem, they come up with 10 solutions. We take it for granted, but believe me, they are going to change everything what we do, especially in the area of healthcare where we are involved.
Okay, so thank you very much, Dr. Devi Shetty. We have to close this session. I think the organizers have a small memento for you. If you can come to the center of the stage.
Our next speaker is Professor Sriram Ganapathy. He is a faculty member in the Department of Electrical Engineering, IISc. Before joining IISc, he was the research staff member at the IBM Watson Research Center. He received his PhD from the Johns Hopkins University. His research expertise is in signal processing and machine learning applied to speech recognition, speaker recognition, and auditory neuroscience. He's currently co-leading the Artificial Intelligence Center of Excellence in Healthcare at IISc. So he will be talking to us about his work. So over to Professor Sriram Ganapathy.
Hello. Yeah. Good afternoon, everyone. Thank you to the organizers and thank you to Professor Narahari for the warm introduction. Also want to say thanks to Professor Dr. Devi Shetty, who has set an excellent context for the set of things that I wanted to talk about, which is primarily about healthcare AI, but moving from hospitals to primary health to public health and at population scale. So the whole set of activities is primarily motivated by looking at a subset of healthcare, which is on the NCDs or non-communicable diseases. So when there was an interest for IISc to participate in the AI Center of Excellence, call for proposals and so forth, it was a conscious decision taken to focus on NCDs or non-communicable diseases. And the reason for that being is some of the statistics that have come out from, let's say, from 2000s to more recent, where the infectious diseases, which were the primary cause of deaths in the early 2000s, has now moved to the secondary cause, and the primary causes now have become the non-communicable diseases. And several reasons could exist for this. Some of that most of us already know: substance abuse, issues like unhealthy diets and physical inactivity and so forth. And a lot of things that Dr. Devi Shetty mentioned in terms of coronary artery diseases, diabetes management, cancer, respiratory diseases, they all form part of the NCD management. And the other aspect related to NCDs is that many of these are preventable, at least they can be delayed in terms of the fatalities that they cause. So the question then was, how can AI help this situation? Right, so if you look at healthcare AI, some applications were discussed in the last session. But if you look at, let us say, overall last 5 years, has AI really taken the leapfrog in healthcare? The answer is perhaps no. In fact, many studies in the last 6 months or 1 year have shown the opposite of it, which is to say that AI has not really translated to the promises that it has for other technologies, like, for example, NLP or finance and so forth. AI has not really delivered that level of success in healthcare. And some of the reasons for this is the bar that healthcare sets is much higher. The deployment metrics, which is moving from labs to, let's say, to the field, in hospitals, in public health, and so forth, is a significant bridge. So then the question is, this is the key issue that modern, AI applications have to take care of when applied to healthcare. So the government of India, under various initiatives, has been trying to push for democratizing AI technologies. The fundamental thought process being that AI is a mature technology already. It's almost like a tool. Now, how can we take that from the cream of the society, which is largely valuing the benefits of AI, to more layers of the society in different subdomains. And in this direction, the AI Center of Excellence awards were given in various subdomains related to agriculture, which IIT Roper has received. IIT Madras received the Educational AI Center of Excellence. Sustainable Cities went to IIT Kanpur, and we have been, let's say, fortunate to have been awarded the AI Center of Excellence in Health. It has been operational for about 5 months now, and that is the set of activities that I'll be describing the next 8 minutes. Right, so what are we doing slightly differently in terms of healthcare technologies when it comes to AI for health, right? So the fundamental direction of protocols, design of studies, of identifying problems to work with, we take an AI-first approach, which essentially means to say that when you collect the data, when you get the first piece of information about the patient and so forth, all the way up to treatment or suggestions, advice, counseling, etc., we want to ensure that these are all digitized, these are all consumable by modern AI technologies, and therefore that becomes core to various technology development. And then the other aspect is not just on the research and development, but also on the deployment of these technologies, in particular to use software as medical tools, as devices, and to go through various approvals in the country to get this as SAMDs, which essentially means software as a medical device. Safety and ethics. So this is significantly important because healthcare is personal. It is also individual. It also has lots of other domains that AI typically doesn't address in terms of fairness, inclusivity, in terms of somebody mentioned about explainability and so forth. So all of these aspects somehow have to come in play when AI becomes part of the healthcare system. So then just very quickly going straight at where we try to focus. So we call ourselves the TANU, which stands for Translational AI for Networked Universal Healthcare. And if you look at the continuum of care cycle that individuals go through when they identify themselves as patients or persons at risk, is that they try to seek care and then they go through the current arrival at the first point of care. This could be your health workers, nurses, ASHA workers in a semi-urban or rural settings. And then some diagnosis is done, and then they are typically pushed into the subsequent chain of the healthcare, which involves treatment of the disease or definitive diagnosis through other sophisticated tools, etc. So when we proposed the AI solutions, we said that we want to work at the first point of care. This is where the widest margin of population comes in. This is where also there is the significant source of error. Right? So typically the non-physician health workers, the nurses, the ASHA workers, ANMs and so forth, they generally tend to lack the medical or clinical knowledge that is needed. And they also have significant resource constraints. Like, you don't have definitive diagnostic tools, you don't have ultrasound and other sophisticated scanning devices, and they still have to make certain decisions about the person that is coming in to seek the care. So this is where we felt that, the knowledge of having more data, which can be summarized through AI technologies, this is where they can play a role to improve the efficiency of the system. Right? So this is fundamentally where many of the healthcare solutions that we are trying to operate on come from. So again, in terms of the various topics that are of interest in TANU, these are primarily in oral cancer led by Professor Rajesh Sundaresan here in ECE. Fanindra Elavarthi leads the breast cancer solutions. Chandrasekhar from electrical engineering, he leads the retinal care solution. Diabetes management is led by Professor Jayaprakash from IAP, and I work on the mental health vertical. So all these are primarily the verticals that are directing the solutions to NPHWs or non-physician health workers as tools. And fundamentally, they are all going to be device agnostic, meaning they have to become an app. It resides in the cell phone, the smartphone of the health worker. It is going to enable them to perform the diagnosis, early screening, in some cases, management of certain NCT conditions. So the whole agenda or mandate of the AI Center of Excellence, while developing these AI models, it also has to walk through all the paths of typical healthcare technology, which means to say that all of them have to go through ethics and approval of the ethical committee, scientific board. Models have to be developed with data collection from the field, validated, and then gone through, let us say, pilot deployments, then subsequently to the DCGI, which is the equivalent of the FDA in the country for regulatory approvals. And then also, we have to work through our systems to develop platforms for final deployment of this, in particular integration into the DPI or the digital public infrastructure. So among the 5 verticals I mentioned, these are really the various stages at which they are at. So oral cancer, for example, is at the most advanced stage at this point. It is under the regulatory consideration for approval with the app, and rest of the verticals are like, more like work in progress between 1 and 2 stages here. So very quickly, I'm going to talk about some of the things that also came up in the discussion that happened in the end of the previous talk. So one of the key aspects that was mentioned was like, if basically a data point, let's say in this example schematic I'm showing is an MRI scan of the brain. So the common machine learning pipeline is to basically take it and treat it as a classification problem. And then, the question that I particularly liked at the end of the previous talk was the comment that, there is a person coming with a cancerous sign and the model misses it, or the vice versa, the model comes up with a false positive. Both are equally bad. So what we have been trying to also do in my lab, and which also we want to extend to some of the solutions we provide to the AI Center of Excellence, is to have models to, in addition, providing classification outputs, generate confidence estimates, generate trustworthy responses, meaning to say that, okay, I am feeling that this individual scan is cancerous, but this is the confidence I have in it. And now you pass on both the decision and the confidence to the human in the loop to consider when they make the decisions. So why we need all this is because there is insufficient data, mismatched data, there is noisy data, medical domain. You never really have complete diagnosis at any point in time. You always want more data from the patient. But at the same time, we were training and testing maybe mismatch, which means that you have situations where data is also going to be out of domain for the models you have trained. So in these settings, sometimes models even exhibit hallucinatory behavior. Sometimes they are going to perform very poorly in certain conditions. So now can the confidence estimate be a reliable metric that you output that can be taken into the decision process? So I'm not going to go into the details of the machine learning aspects that have helped us do this, but primarily to say that with more sampling, with more inferences, with more analysis with the model, one can come up with some uncertainty metrics, which essentially, the whole scheme of things, help models to also say what we commonly do as humans. If you take, let us say, a nurse, if you take even doctors with certain medical data points, they commonly say, I don't know, we need more tests. Right? Now, models also need to have this, that if there is insufficient evidence to decide in one way or the other, we want to enable models to say, I don't know. Right? So now you can pass it on back to the human and then therefore back to the chain to do more definitive diagnosis, to pick up that thread and then further probe to get a definitive response. Right? So looking forward, I have a slide or two. I know that I'm running out of time. So looking forward, just to highlight what we are going to move in, is there is basically a pyramid. We call it the healthcare pyramid for AI implementations, where we want to work on pretty much edge AI for various solutions, a no network, very low or no cost solutions that are almost instantaneous, that can be widely deployed population scale. And they provide instant responses to move people up the chain in the health system. And subsequently also, or in parallel, there is also a need, a demand that Dr. Shetty was mentioning in the higher pyramid of the healthcare chain, which is to have, let's say, a lot more data that you can find, particularly in a hospital setting. Incorporate all of them, you will have network access and so forth. What can you additionally provide? As we saw in the morning's talk about various advances that LLMs and large language models for specific health applications also have made, can we put them to use to direct them to particular use cases of this nature? And certainly there is a middle level also where we can combine the benefits of both ends. And last but not least, while we are working on all these data resources in the public health space on various verticals, the country level program, I could not go into details of any of these solutions, but trust me, all of them are operating at different points in the country collecting data. So they all become part of what we call as potentials to unlock in terms of the health foundation model. So again, all this work is happening not just by us, with a slew of partners, various hospitals, AIMS hospitals in Delhi, as well as in other places, as well as private hospitals that are being partners, data vendors, and deep tech partners and solutions for all of these verticals. That is pretty much all I had, and thank you for your attention.
Thank you. Thank you for a very, very nice talk. We have time for a few questions.
Hi, Professor. I'm Subramania from JP Morgan Chase. So it was a very excellent topic delivery. I have a very, it might look funny, but I saw in one of the slides you're talking about you're working on the mind and that part of the game, like the mental topics.
Yes.
So
I don't know, the slides have gone out, but I can respond anyway.
So the question is like, see, that topic itself is a hallucinated topic.
Not really.
I mean, the way we perceive it.
So what we work on is mental health for common mental health disorders like depression, anxiety. substance abuse, cognitive impairment, like, age-related cognitive degeneration and so forth. So how can you build, let us say, speech, language, technologies, questionnaire-style data to assess? And this is also, again, at a public health level, that people are not necessarily opening up about what situation they have in terms of mental health. So how can we design like technology interventions that can enable them to understand even. So when we talk to, let's say, the health workers and so forth, they say that there is real stigma, and also even the health workers and so forth are not pretty skilled to understand depression or anxiety related issues. So how do you now use AI to augment that existing workflow of identifying common mental health disorders?
Yeah, my question was on the same line, but it's a bit different. That so considering that topic itself is a bit hallucinative in the general perspective, and we are talking also about the possibility of hallucination interferencing in the healthcare system.
Yes.
So if you take India, let's take Nimans as the best example.
Okay.
If you go to Nimans, on a given day you will find 100 different patients of same disorder with different variations. Right. So how good are we in decoding that level of scalabilities?
So So in case of, I think now I get your question a little bit better. So we were asking about the hallucination that machines exhibit and how one can. So what happens is, like, you check the robustness, right? So let us say, if current systems, let's say even LLMs for that matter, if you change the prompt a bit, you get a different response in many cases, and that is definitely not a desirable property. So we turn that into a way in which you can quantify the uncertainty. If I change the input data a bit, how robust is the model to access that we should not really care about, right? If I rephrase a question, right? If the model gives a totally opposite response, then I know that model is not trustworthy anymore, right? That is how you play the game, how you construct this. You create agents to take your input data and manipulate it in different ways that they're actually very similar, but perhaps might generate a different response. And when you know that it's generating a different response, it automatically means it may not be trustworthy.
Thank you.
We have time for a very quick question.
So right now in the world,
Go ahead.
Right now in the world there are multiple different LLMs, right? There's ChatGPT that works on data that's preloaded, and there's Gemini that has access to the web, and it gives you kind of data. So I have two questions combined together. So what kind of AI are you guys using in terms of the intelligence level? How are you determining which intelligence out of which LLM is the actual intelligence that you must use? And also, how is the patient's data confidentially protected? And since AI cannot think because thinking requires consciousness, how does it actually, it is basically prediction and the highest prediction that it can actually do based on data. So how are you guys choosing which is the LLM model, or are you building your LLM model for these kind of interactions with the patients? That's the question, sir.
So there are multiple facets. I may not get into all of them, but the quick comment on what you asked, we take technologies that actually, you compare a plethora of them, and we also collect data from the field in public health as well as in hospitals and so forth. We try to benchmark and then take the decisions. And second important aspect, as I mentioned, is some of them have to run real time. Because if a health worker is having a conversation, if we have a consultation with the patient, if you say, can you wait 5 minutes, I will get a response for you, the patient is going to walk out because there is no incentive. But if you say that, okay, I see something suspicious with an early model that I have that I can run through my phone itself, and now you ask them to wait for a more detailed diagnosis, yes, you get a chance for running a detailed diagnosis. So again, there is a hierarchy in terms of the modeling also that you can pick up. Early models, very nimble, very fast, that run out. So for example, the oral cancer I mentioned, they run a mobile VIT model. So which is very fast, less than 30 seconds is all it takes to run an image through that model and get the response.
Awesome, thanks.
Yeah. I think just one more question.
Good afternoon, sir. Thank you very much for your insight.
Thank you.
In fact, this is related with the explainable AI. Nowadays, the critical domain like health and finance, trustworthiness is an issue basically. Especially in healthcare, the patients are not really trusting on the opinion given by the human doctor. And that is why this kind of technology is coming up. XAI with Sharp, Lime and Captum tools, right, which gives importance factors based on which the decision is taken. basically reasoning about decision taking.
Right.
Right. So, is there any benchmark? Like, for example, I'm performing some
Request
experiment.
you to be very brief with your question, please.
Yeah. In fact, suppose I have taken a particular disease, and I want to reason behind whether the patient is diabetic or not.
Right.
So, using that tool, is there any benchmark which can say that yes, we can take the decision properly?
Absolutely. There are benchmarks for reasoning, there are benchmarks for chain of thought and so forth. And even in trustworthiness, what you do as a benchmark is, let's say when the model is less confident, is it also less accurate? This is the benchmark you compare. Like if the model is saying I'm low in confidence, is that region where it makes the most errors? If that is the case, then you have a very good predictor of its accuracy itself. So that is really what you want in the confidence metric. So we use those benchmarks to compute whether metrics are
in that
valuable.
case, we need to take opinion from the 2-3 human doctors, sir.
100%. 100%.
Thank you.
Okay, looks like there is time for one more question.
Okay.
I had one question.
Okay.
Oh,
but
okay. Sure.
Yeah.
But then I need to give you time for sure.
This is Srinath here, and I work with Karnataka Digital Health Society.
Thank you.
Question for me is, you talked about a confidence level, right? So you said this is identifying this cancer at 65%. Now, if you want to democratize this, I would like to see the PHC doctor in the rural area take a decision on that. Now, if it is 80%, is it really 80%? Can there be mistakes because of, I mean, if it is 100% is fine, if it is 0% it is fine. At 60 or 80%, what do you suggest they should be doing?
So like, this is a bit like, the game where, both parties come into play, right? So when one of the models, as you rightly said, let's say human is making a decision, and let's say model is making a decision, as you said in the PHC case, right? If one of them is very sure, then it's very easy, right? It's the case when, let's say, doctor is, let's say, little unsure, and then they consult the AI. And if the AI is also unsure, then they know that, okay, it's not like, I have to take a decision, then we can refer or make another test or do more different consultations with the patient. It is also the case when, let us say, the doctor is basically looking at the AI and suddenly the AI is very confident about a decision. It reinforces what the doctor had in mind. Maybe the doctor was not initially very sure, but the AI is giving a high confidence. Now it becomes a more definitive diagnosis to take forward. So all you are saying is you make all the decisions, but you provide also this number, and wherever it matters, you can use the number for additional decision making.
So as a part of the TANU initiative, I wanted to know what kind of collaboration you have with clinicians and also hospitals.
Absolutely. I had a slide. They did not load that version which I had, but we have about 30 odd partners right now in terms of various key hospitals, doctors in the country. So for example, one of the first partnerships we had with AIIMS Delhi, and then with various other AIIMS chain of hospitals. In Bangalore, we have partnerships with NIMHANS for the mental health things that I am running out of. Then also Manoshanti clinics. Then various set of NGOs like Sangat and so forth who work in this space. Other IITs, we have partnerships like IIT Kanpur is one of the partners. IIT Bombay is another partner in certain projects. Then there is a set of also public health, like, sittings. For example, the oral cancer runs a bunch of activities in UP and Tamil Nadu. So this is run through the government of Tamil Nadu in Tanjavur, in Krishnagiri and so forth, as well as in Varanasi. So they work with the NHMs, the National Health Missions there, to form partnerships, to form, let us say, agreements, and then run data collection, pilot deployment, the model development, and so forth.
So thank you very much for this excellent talk on TANU. We wish the TANU initiative all success. So. So after the talk by Professor Srinam Ganapati, our next speaker is Mr. Shobhit Banga. He is co-founder of Josh Talks. Shobhit is the co-founder and CEO of Josh Talks. He grew up in a small town in Himachal Pradesh and dropped out of school in the 9th standard. He started Josh Talks in 2015. Today, under his leadership, the platform reaches over 200 million monthly views across 10 languages, has millions of app users, and it is known for its work in voice data solutions. He has been recognized as a Forbes 30 under 30 in Asia. So I'm sure all of us will be very interested to listen to Mr. Shobhit Banga. Over to Shobhit.
Thank you. Thank you. All right. Thanks a lot for having me, Professor Sriram, for inviting me, and all the organizers for putting this together. I'll start with, I think a widely accepted idea is that the primary medium of interaction between man and machine is going to be voice. I think today the way we interact with the computer primarily is either through touch or through type. And over time, if we see history and how humans have interacted with a machine, it has evolved. I think if you've seen the Steve Jobs versus Bill Gates YouTube documentary, there's this part where Bill Gates is putting punch cards into a machine to code it. And I think over time, if we see, it went from the punch cards to typing in during the time of MS-DOS. Then graphic user interface came in with Macintosh and Xerox. And the iPhone brought touch. At least the multi-touch screen came to all of us. I think if you see when this happened, every time this change happened, where the primary medium of interaction between man and machine changed, it unlocked massive value. So if you see the number of companies that got built with every single change, the number of internet users or people who got access to the computers drastically increased. So if we see, this movement has been towards being something that's more intuitive to humans. And I think voice is the most intuitive way for humans to interact with each other, even much more than touch. And once that happens, I think it will unlock so many possibilities that we don't imagine today. For example, when touch happened, we couldn't imagine that probably something like an Uber will now exist, but it happened because the iPhone happened. So I think the change to voice, when the primary medium of interaction between the machine and humans becomes voice, it will lead to a mind-blowing impact in the new kinds of tools and services that get built. So at Josh Talks, we are incredibly excited about contributing to making this change happen. I think there's something even more intuitive than voice, and that is maybe if Neuralink works and if we can just think and it happens, that would be super cool. But I think for now, we'll stick to the voice bit. So we did something interesting. It is the narrative around voice AI is that it's become really good and at least it's usable and there are so many tools and services around us. But if I really ask any of you today, since the morning, it's around 4 o'clock now, 3:30 now, how many of us have actually significantly used a voice agent since the morning? Any of us have had very significant usage with a voice agent since morning? I think that's maybe like one person, right? That's like one person out of this audience of maybe 150 to 200 people. That's staggering. There is something going on that is not working. I'll give you another idea here. The mean opinion scores or the MOS scores of the latest TTS models show that the MOS is at 4.6. Models are claiming 4.6, 4.7 MOS on a scale of 5. Then where is the usage? There is something that is broken in the middle. So what we did is, this is not a research grade study. This was an internal study we did to get a sense on this feeling that we have that voice AI is broken. Can we get a sense on what the users actually think? So we went to about 100 users who have nothing to do with technology, who don't create products, who are just the consumers of the internet and of computers. And we asked them to rate that if the interaction that you have with your mother or your father is 5 on 5 human, on that scale, where do voice agents today stand? So some of these people are the users of things like Alexa and Siri, but they're also the users of the ChatGPT voice mode and the Grok voice mode and so many other voice agents that we have access to today. And it's staggering that the average score that we got is a 2 on 5. People feel that voice AI is at a 2 on 5 level of humanness. And somewhere, I think I would agree. I think this shows a lot more that why out of 200 people, nobody has used in a significant manner a voice agent today. So I think if we see what is exactly probably happening here. So a voice agent is essentially a speech recognition model, a large language model, and a text-to-speech model. It goes from the ASR to LLM and TTS and somewhere latency. So somewhere between these 4 functions, the performance of a human is way better than the performance of a machine. So let's look at this. So a speech recognition model, it is said that humans have a word error rate of like 3%. So out of 100 words I've spoken, you probably understood 97. In a real world scenario for Hindi, this data is more like 25-30% error rate. So out of 100 words spoken, only 70 are actually getting understood. There's a LLM issue here that what exactly has to get responded. Today, if I speak to ChatGPT, and I was speaking to ChatGPT in the morning trying to use the voice mode, if I say a 3-minute long prompt, it will respond for 1.5 minutes just saying the same prompt back. Essentially, it's not built to have human-like conversations yet. And then there's the text-to-speech models. You know, I made my nani, my grandmother, here the Grok text-to-speech mode, and they claim that it's really good now. And she didn't even know that it is an AI model speaking and not a human speaking. She instantly rejected the idea of communicating with that voice. She did not even know it's AI. There is something here that the MOS score is missing. And then there is the issue of latency. A lot of you, while I'm speaking, are instantly doing a nod as a response to what I'm speaking. This is taking you under 130 milliseconds to do. And AI is doing this in probably 700, 800 milliseconds. So somewhere within this, if we bring these metrics down to human level performance, maybe not 1, but maybe 150 out of the 200 of us would probably be using voice models today. Here is a short video of, to show you actually how far we are from what's actually happening in voice AI today. I think there's no audio, right? Yeah, okay. So essentially, we'll just let the video play in the back. It's a simple prompt. Actually, we can do this right here. So how many of us have the ChatGPT app on our phone? Okay, can we take out our phones, open the ChatGPT app, and ask, okay, let's do it together. So can you take out your phone and open the ChatGPT app? Yeah. In the prompt screen, you will have a mic button right next to where you can type. Click the mic button and say this individually. Aaj ka mausam kaisa hai? A simple prompt. Aaj ka mausam kaisa hai? All of us, let's do it. What did you say? Can you say that out loud? In Urdu? Did you speak in Hindi or in Urdu? Isn't this insane? How many of us actually did it and got a result? Okay, how many of us actually spoke in Urdu? How many of us got an Urdu response? Look at this. This is insane. So essentially, these are the kind of issues that we are trying to solve at JoshTalk. So I'll go through this quickly. So essentially, between the 3 pillars of AI, which is compute, algorithms, and data, I think another widely accepted idea is that data is where the misses are happening. I met with the co-founder of Cyril early last year, and I think it is widely accepted in the industry that if we have to make this change happen from 1 to 150 people using, it's going to happen through something that changes in data. So here is an idea. Here is an extreme scenario. What would be the dream ASR Hindi data set? So if we have all of humanity that speaks Hindi, so we together, all the Hindi speakers today are going to speak about 500 million hours of Hindi. So about 600 million speakers are going to say 500 million hours of Hindi today. If we can capture this entire set, so think of this, okay? The interaction I had with my Uber driver coming here, the interaction I had with my mother when she was trying to force me to eat food before I took my flight, every single small interaction that we had in our day, if we could capture that, that would be the ultimate dream gold level data set to train speech recognition models. But I guess that's not exactly possible to do. So here is another idea. What if we have it? What if we have a 1/500th version of that? What if we can actually try and emulate or represent what happens in everyday speech, but put it into 1 million hours per language? So if we are speaking 500 million hours today, we get the perfect representation of that across various different scenarios. Task-based speech, informal speech, child speech, elderly speech, all different kinds of dialects and geographies and variations, and put it into 1 million hours a language. I think that could really do something for speech recognition. This 8-9 people getting Urdu responses, essentially absolutely useless responses and clearly errors, would not happen. So essentially, what would this 1 million hours data set have? I think a lot of this is pretty clear what it needs to have. I'll just move on in the interest of time. So essentially, at Josh Talks, what do we do? So we never did this. How many of us have heard of Josh Talks, irrespective of the voice scenario or this conversation we're having today? Heard of Josh Talks? Yeah, wow, fantastic. Yeah, that's, ये मेरी 12 साल की मेहनत है. That so many people know about it. So essentially, Josh Talks is a media company. It makes talks. It's like a TED Talk, but for people at the grassroots of the country who speak our languages and our dialects. We had no business in being in voice. But 2 years ago, we realized that actually one of the big techs, one of the world's premier foundation model labs reached out to us and said that, we actually have access to users in the remotest parts of the country. 200 million people watch a Josh Talks every month. About 8-9 people, 10 people were here. 30 million people are subscribers of Josh Talks. We started to reach out to them and say, would you like to contribute to generating this data set? So about 1.5 million people, about 15 lakh people are now contributors to the data set across various languages. I actually traveled to all extreme parts of the country to try and understand that why is nobody using voice AI and why does it suck so much? And this is, for example, me on the Nepal border in Bihar, in Jayanagar, with a family there, who is one of the annotators. Every single person in this family is now a contributor on the Josh Talks platform, and they contribute the voice and annotations. Yeah. So what is the work that we've exactly done towards this idea of eventually generating this 1 million hours a language? So we have a lot of natural conversational speech data sets. So we have now collected 50,000 hours per language in India, close to about 500,000. A lot of other work. So a lot of work in healthcare has happened, like what Professor Shriram was speaking about. I'll just show you quick photos of the work here. So we are actually going into the villages of the country where the ASHA workers are actually working. So these are some of those recordings happening. So I'll just show you what these rooms are. So this is a play school. That's an ASHA worker speaking to a patient. That's one of our annotators collecting her audio. Now imagine how noisy this room is, what is actually happening in this scenario. And this is a phone kept in the middle that's actually capturing the ASHA worker, the patient, and at the back end, this recording is going. And firstly, we are separating the channels out and then actually annotating them. Insanely hard to do. So these are the kind of environments that the audio is actually coming from. Finally, I'll say that data sets are not enough. Benchmarks need to represent real world speech. Today's benchmarks show that the error rate in Hindi is 3%. Maybe 12 of us used it, 6 of us got it in Urdu. It doesn't look like 3% error rates to me. So we need data sets that are actually representative of what is happening in the real world, and hopefully they will be private so that the chance of contamination of the data sets is low and we can actually truly judge which are the best models today. So that's about it. Thank you so much.
Thank you very much, Shobhit. We have time for maybe a couple of quick questions only.
That's okay.
Looks like everything is clear. So those of you who would like to talk to him should catch him offline. So thank you, Dr. Shobhit Banga.
No,
right?
no, it's just Shobhit.
No, we are giving you doctorate.
Great, I'm
right?
great. I'm
So
happy.
sure. Thank you for a wonderful talk.
Thank you so
wish
much.
you all the very, very best.
Thank you so much.
As a small token.
Thank you.
So like in the morning, we had another extraordinary session. Let's put a hand for all our wonderful speakers, Dr. Devi Prasad Shetty, Dr. Sriram Ganapati, and Dr. Shobhit Banga. So this concludes the session. Over to the organizers for the next program.
We now move to an engaging panel discussion, Building AI Systems at Scale, Policy, Funding, and Technology Gaps. Mr. Anirban Sarma is the Director of the Digital Societies Initiative at the Observer Research Foundation. His research explores issues of technology policy with a focus on a digital economy, platform governance, AI, digital public infrastructure, sectorial applications of ICTs, and the future of work. He was the chair of Think 20 Task Force on Digital Affairs during the Indian and Brazilian G20 presidencies and the Chief International Outreach and Communication Officer at the National Digital Library of India. He earlier served at UNESCO, where he led the organization's initiatives on tech for development across South Asia for nearly a decade. I invite our moderator on stage. An introduction of all the panel members. Shri T. Bhubalan IAS is an IAS officer of the 2015 batch and currently serves as the Chief Executive Officer at the Center of E-Governance, Government of Karnataka. With a background in computer science from PSG, College of Technology, and public management from JNU, he brings hands-on experience across central government, district administration, urban governance, and smart city initiatives, offering valuable perspectives on technology-enabled public service delivery. Please come on stage, sir. Mr. Prasad Unikrishnan, partner and leader, is a senior consulting leader at Grant Thornton Bharat LLP with over 2 decades of experience. He has led large-scale digital transformation and AI-enabled governance initiatives, working closely with central and state governments and multilateral institutions, and brings practical insights into digital public infrastructure and responsible AI in governance. Please come on stage, sir. Dr. Prateek Jain is a distinguished scientist at Google DeepMind India, where he leads the machine learning and optimization team. Mr. Venkat Padmanabhan, the Managing Director of Microsoft Research India. Mr. Ankit Bose, Head, NASCOM, AI and CEO, Center of Excellence for Data Science and AI, Responsible AI Hub, is a seasoned technology and business leader with experience across engineering, consulting, strategy, and service delivery.
All right. Thank you very much for the introductions, and a very good afternoon, colleagues, and a warm welcome to this panel on building AI systems at scale. As you know, our discussion today is taking place within the framework of the AI Impact Summit's working group on resilience, innovation, and efficiency. Now, conventional AI development, as we understand it, has become a very resource-intensive and expensive proposition. Large AI models need enormous amounts of computational power, vast data sets, and they are massive energy guzzlers as well. And just to give you an idea of the scale of what we are talking about, it cost $100 million US simply to train ChatGPT-4, which many of us use. And the model was trained on some 13 trillion tokens of data. The power needed by advanced AI models is doubling roughly every 100 days, driving up the demand for electricity and water. A typical AI-focused data center today consumes about as much electricity as 100,000 households. And some of the latest ones which are currently under construction consume 20 times as much. All right, so these are staggering figures. And being water guzzlers as well, this is proving really quite detrimental to water scarce and arid regions, all right? Many of which happen to be in the global south. So we can see right away that there's a convergence of economic, environmental, and accessibility hurdles when it comes to building AI at scale. High resource requirements often put the creation and use of AI beyond the reach of most economies, especially those in the global south and developing countries, which also means that many of those who could have benefited most from AI tend to be excluded. And AI's resource intensity is also why less than 1 in 5 companies manages to scale AI successfully and sustainably. So the big questions before us today are, how do we integrate efficiency into AI development? How do we make AI not just more affordable and accessible, but somewhat more responsible as well? And what sorts of policy, funding, and technology gaps do we need to address in the process? So we have an excellent panel to help us understand these issues better. So once again, it's a pleasure to introduce Mr. T. Bhubalan, CEO of the Center for E-Governance at the Karnataka government, Dr. Venkat Padmanabhan, MD at Microsoft Research India, Dr. Prateek Jain, Distinguished Scientist at Google DeepMind, Mr. Ankit Bose, the head of NASCOM AI, and Mr. Prasad Unnikrishnan, partner and leader, Digital Government and Transformation Consulting at Grant Thornton. So let's dive right in. We actually have quite a lot of ground to cover. So Mr. Bhubalan, if we might begin with you, sir. Now, the Karnataka government has a very progressive vision for AI-enabled transformation. And your IT policy 2025 to 2030 partly lays this out. You also have a dedicated data center policy and a host of other initiatives, including an AI city and AI centers of excellence. So how do you think the state is trying to build the idea of efficiency into its development and innovation efforts?
So good afternoon, my fellow panel members and all the audience here. So the government of Karnataka has always been a pioneer in introducing new digital technologies for the betterment of citizen in terms of the citizen empowerment as well as the public service delivery. So over the last few years, we are increasingly adopting the artificial intelligence in all our initiatives. For example, recently we have rolled out an application called Kartavya for the attendance management of all the government employees, which is completely AI based. And similarly, we are coming up with a initiative that is for capturing the attendance of school students based on the artificial intelligence that is expected to reduce a lot of malpractices and improve the efficiency in the government system. So the government of Karnataka has always been supporting our initiatives and has adopted the values of responsibility and efficiency in the policies that are being introduced by the government. For example, the IT policy that you have mentioned has an exclusive charter for the adaptability of AI to ensure the productivity in the government system and also how it can support the industry and the startups. So our data center policy again talks about AI, how we can use the AI to ensure the state government digital public infrastructure, including the data center, can have a shared infrastructure, and how we can use this infrastructure without having an excessive cost for our shared projects. Similarly, the government of Karnataka, with the contribution from government of India and private partners, are going to launch our own center of excellence for public sector using the artificial intelligence, and we are going to have collaboration with the industry, with academia and everyone. So the overall motive of our Karnataka AI cell is to have efficient and responsible systems that are going to help the state of Karnataka and its citizens. And with respect to the efficiency factor that you were mentioning, we do have a certain thought process when we see that concept across the different dimensions. So we can have multiple discussions. For example, efficiency, how the AI system can bring an efficiency in the governance, how it can reduce cost, and how it can reduce the workload of the officers and staff. That can be discussed in detail. For example, the other day I had a interactive session with the UNDP and the judiciary. So we were discussing about how the AI can be used to reduce the workload of the courts in India and how it can benefit the citizens across the country. Similarly, efficiency in using the infrastructure. So being the nodal department for vetting all the e-governance projects in the state of Karnataka, whenever the committee convenes its meetings, we see some projects having similar nature, similar specification, but coming up with a new proposal. So how are we going to reuse the existing system, maybe with some tailoring and tweaking instead of going for a reinvention of the wheel, which will essentially increase the cost, increase the system load, and overutilization of the infrastructure, all those things. So efficiency in that aspect is very important for public sector, because in private sector you may not be having to use the same kind of infrastructure again and again for using these AI based applications. But in government, more or less, we will be having the similar necessities across the different departments. So efficiency in that aspect is very much important. Then our government actively promotes the efficiency in terms of innovation. So it should not be a standalone factor. Innovation has to be shared by the government, by the industry, by the academia, by the startups, everyone. And we have to adopt the best practices across the globe, and we have to find out if that can be suited to our needs and requirements. That is very important to ensure the optimal solution is achieved through these kind of initiatives. Finally, as I have already mentioned, the shared visions and shared infrastructure will essentially lead into improved efficiency. At the same time, we have to ensure that we are efficiently handling the important aspect of the data privacy. So we have lot of data. We have data across different domains and platforms, and the interoperability of this data is itself is a question mark, because we have multiple databases, data sets used by different departments. So this fragmented data has to be integrated first of all, and the user has to be notified on the use of his personal data at least, so that he will be able to take informed decisions on how his data can be used and managed. So efficiency in AI system is such a huge discussion, and we can have multiple dimensions to that. And on behalf of Government of Karnataka, I assure the audience that we are taking each and every possible measure to ensure efficient and responsible use of AI in our system. Thank you so much.
Thank you very much. So that's quite extraordinary, and I think that also sets the tone for our conversation very well. So thank you for that. Dr. Jain, if I might turn to you next, and you're uniquely placed to answer the next question also, because you are the Gemini model design research lead, right? So what we wanted to ask you was, when designing and building a large language model, what steps can be taken to reduce its overall resource intensity? And if one tries to do this, does that compromise its results and its scalability in any way?
Yeah, no, that's a great question and a very pertinent one that all of us grapple almost on a daily basis. I think a lot of science and engineering needs to go in making the model training as well as model deployment a lot less energy intensive, and if possible, some bit of co-design. So to sort of, sort of go in a double click on these things. So science becomes very critical because like folks have shown that even by looking at say models at the size of 100 million or 200 million parameters, you can estimate how its performance will be at say billions or trillions parameters level. But that science is still not completely nailed down. That is still many times when we try to scale just based on very small models, we do find a lot of surprises. So as we keep on making that science better and better, that by just training very small models, if we can predict how our largest models will train with really large amount of data, that then helps ensure that most of the cost of development is focused on very small scale models, and then you only need to sort of train very large model once in a while. So that becomes a very important aspect. Another then aspect comes in around engineering, where for whatever workload you are deploying your model on, you want to make sure that you are using your accelerators in the best possible manner. So today Venkat gave a talk around how you can sort of utilize the GPUs well for prefill and decode. So there is still like fair bit of headroom there, and if we can ensure that we can utilize our like infrastructure as well as possible, that then brings down the cost significantly. And then once you sort of finish that avenue also, then the third avenue is of that of co-design. That is, if we can ensure that that the workload that we care for is very close to the strengths of the actual actual device that we'll be deploying it on, then we can ensure we can actually unlock significant, maybe like an order or two order of magnitude cheaper solutions in terms of energy. That is, currently whatever energy cost we have to pay for, let's say one query, we might be able to unlock, say, even 1/10 or 1/100th of that cost. But that requires very careful co-designing of both the hardware as well as the model and the algorithms that are used to train and deploy those models. And it also sort of requires fair bit of infrastructure being built around not only the chips, but the compilers and the debuggers and everything. So fair bit of work, but it is like, it seems like that will be something that we will need if we want to build more powerful models that can support wide range of tasks that we care for. In terms of giving up on quality, well, like obviously there's always a trade-off. That is, if you go to smaller scale models, or if you are sort of much more heavily quantizing the models, you do end up giving up on quality. But again, for certain domains, certain scenarios, you might be able to get away with that. So also by taking the existing models and trying to make sure that they work for you in your case properly, by tweaking various parameters and all, that also might be another way of ensuring that we are getting most sort of throughput out of, say, every watt of energy that we are putting in the system.
Thank you. Thank you for that, Dr. Jain. And in fact, we'll just pick on your point about energy efficiency and delve a little deeper into that. So, Dr. Padmanabhan, if we might turn to you next. Microsoft recently committed to invest $17.5 billion in India. And a part of this will be used to build hyperscale infrastructure to run AI at scale. So how might this and other AI infrastructures be made more green and sustainable with respect to their energy and water use?
Thank you for that question. It's a really important question. Yeah, so, Microsoft has a global commitment to being, carbon negative, water neutral, or even water positive. Right? So that is a public commitment. I think there are some goals. I'm sorry? Can you hear me? Yeah. So I was saying Microsoft has a global commitment on being, carbon negative, water neutral, or even water positive in the next few years. Like by 2030, there's public commitments, and those apply just as much to India as well. Right. So, for example, I think we already have 3 data center regions in India, in Pune, in Chennai, and I think in Mumbai. We're opening a 4th one in Hyderabad. I think it should be open this year. And that is going to use a closed loop air, system with air-cooled chillers. So essentially, the water is in a closed loop. So there is no water usage other than what is started, right? So essentially, and then if we do things like rainwater harvesting, we're actually water positive. So that's on the water side. On the power side, we are definitely expanding our use of renewable power. In fact, in India, we had signed a big agreement, I think a year and a half ago, with Renew Power, buying power. So I think, so those are sort of some examples of things that are happening in production. Now, in terms of research ideas, this morning in my talk, I touched on this idea of green fencing, essentially looking at new ways of combining computation with renewable power. So instead of taking power to where the compute is, take the compute to where the power is, and thereby avoid the transmission bottleneck. Right? So those are, those are research ideas. And the final thing I'll mention is more indirect ways. For example, using AI to help optimize the operation of a solar power plant. And looking at the weather signal, looking at sort of pricing signal, and then figuring out how to operate these plants, and thereby essentially renewable power more viable for more use cases. So I think there are all 3 levels at which I think opportunities Microsoft is doing it, and I think the industry is looking at this part.
No, thank you. Thank you for that. And, another reason why I happened to ask you this question was, it was fascinating to read just a few days ago, last week, I think, Brad Smith unveiled the plan for community-first AI infrastructure in the US, right? And I think many of these principles are also already, in a sense, being adapted to AI infrastructure here in India from what you just said, right?
Yeah, I think the principle is very simple, right? We don't want to build AI at the expense of society, right? So I think that is the core principle, and then all these things follow.
Thank you. Ankit, we'll come to you now, all right?
Yeah.
And let's switch a little and look at the policy side of things now. Now, you work with tech businesses across India, as well as states at the central government. And as things stand now, do you see any gaps in funding options and policies in general for AI development? And how do you think these can be addressed?
Okay, I think a great question, a bit loaded also, but again, let me answer. So, if I see, right, I think where we are globally, right, India is supposedly 3 in 1 ranking and probably 10th in some ranking, right? But again, the leaders, China and US, or US and China, are far ahead of us, right? So we are very much behind them, right? It's a big gap, right? So if we have to cover that, there has to be very fundamental shift in how we are operating, right? In terms of policies, in terms of funds, funds by government, funds by VCs, right? Collaborative efforts, all of that, right? So I think right now, there are a lot of focus from government and probably the ecosystem to do something, right? But everything is happening, in a way that they are not linked together, right? It's like an fist versus fingers, right? We have to make a fist, and then perhaps we have a chance, right? That's the first point, right? Again, specifically on areas where we can work progressively, right? The AI race, if we see, we are like 10 years behind, right? We have to work at least on the next, bit, probably quantum in AI in sectoral, right? AI in social impact, right? I think those are the areas we have to catalyze, which can really impact the country at large, right? And at the same time, we can build something which is not available. If we solve the problem about education for 1.5 billion people, and essentially we are solving it for everyone across the globe, right? Not only the native English speakers, right? Similarly, healthcare, right? If we can provide healthcare accessibility, at large to the mass India has, I think essentially we can take it to every other country, right? And then that will itself give a phenomenal jump, right? Instead of working from a perspective of can we build the biggest LLM model, can we be ahead of the race, can we build a best probably GPU or hardware. I think that battle we are very behind. So let's fight somewhere where we can really have an impact and a chance, right? I think that's that. And for that, I think all the ecosystem, which is definitely government, which is academia, which is researchers, which is industry, startups, SMEs, all have to come together, right? I think that's what I want to highlight here.
Thank you. Excellent answer, really. And Mr. Unnikrishnan, we will come to you now. And you support governments and businesses with their AI transformation journeys, of course. So, what are some of the big trends you see on the tech access and adoption side? Is there any indication of a shift from these big scale-first, resource-intensive solutions to ones that are somewhat smaller and leaner? You see a change happening at all?
Okay, so I need to, good afternoon, first of all, to all of you. I think it's the last session. It's been drop silence in the room. Oh, we need to ease out a little bit first, right? Most of the answers to your questions have been one way or the other mentioned by many of us. So I'll just summarize and then tell you what my conversations have been in the government corridors. That's the most important thing, right? I don't want to say who specifically the name is, but many of the IT secretaries whom we have had the discussions. So everyone goes gaga over AI because they say that is going to improve the efficiency of government. At the same time, you heard the Chief Secretary talking today on a very important point, which they say we don't have all data of the government in one place. It's a data lake or whatever they call it. The third point to it is how clean is your data? How correct is your data? Today in this conference, when I look at in the working group also, when we are looking at scaling up, etc., we are talking about the model and model's accuracy. Model's accuracy is primarily dependent on the data and data accuracy. Okay. So when I had these conversations many a time, I'll give you a classic example here. I don't want to say the name of the state. Somebody has already implemented a small SLM language model on an e-office. Now, it is saying if a government officer gets transferred, another officer takes charge,
Previously, he took almost a month to understand the files. Now he can at least understand the files in 30 minutes. But then the question comes, which Dr. Shetty also told in the conversation. Someone asked very pertinent questions, how accurate, etc. it is. There is something called as tacit knowledge. And this tacit knowledge always remains here. So the officer, in this conversation told me, Prasad, finally I took a decision basis my head clerk who came and told certain specific things which I cannot put on the file, the system. So this is not there in the AI. I'm just telling you. Okay. So when you say adaptability, adoption, etc., from a perspective of government side, the most important question is how clean data you have and how much is the size of the data, and therefore can we build models on top of it? That's the fundamental question. But if you take the private sector from that perspective, or the private businesses, like what Dr. Shetty was talking about, he has already done in last 9 years, etc. They are the custodian of the data which they are using, and therefore they have more willingness to learn, study, adapt, etc. Okay, so if you remove these 3 factors which I told about government, then it is good. Now, second factor which he mentioned, it's very important, which he is talking about, large compute power required to run such models. Okay, that's another thing which we have to look from an adoption perspective. So these are all simple conversations which happen in the room. Okay.
Thank you. We're going to a quick second round, but this time we will not have individual questions for each panelist. It's going to be one common question, and think of this as a slightly rapid fire round. Okay, so 2 to 3 minute answers each. And the question here is, a lot of the innovation for AI resilience and efficiency is likely to be driven by startups in the future. But the fact is that there is quite a body of research that suggests that most startups fail within their first 5 years. 90% of startups, in fact, don't make it past their first 5 years. And that's a rather depressing but true figure. So that being the case, what would your advice be for entrepreneurs and innovators and startups to thrive in this space in the age of AI? So let's sort of reverse direction and begin with you, Mr. Unikrishnan.
It's a very good question, because this also, I would say, you should read the Tamil Nadu Deep Tech Policy, which was released 1 week back, which was written by us. Similarly, Kerala Deep Tech Policy also. The difference is, when you made the point, okay, startups till date were funded by VCs. And we see VCs who are entrepreneurs, who are called as, what is it called as, every day, 6 months to 1 year or 3 years, they put in the money, take it out. In an AI kind of a scenario, and when you're talking about resilience AI, what you're talking about is deep research. Deep research is not a 6 months or 1 year e-com or a app product. It has a lot of cycles of failures and then coming up. That's the first point. For that, the VC kind of a mindset will not help entrepreneurs. What we call is called as patient capital, which means the guy who's investing the capital should be responsible and patient enough to see the results over a period of time. So such entrepreneurs would be not individual entrepreneurs or VCs. It will be more of large market cap companies plus primarily large companies and investors who are dedicatedly going to use such things. So, I don't want to take names here. There's a lot of automobile companies have already decided to invest with Tamil Nadu government. I'm giving an example, okay, with Tamil Nadu government to do this kind of a thing. So that is my take on it. Deep patient capital with a deep tech will take time, and you have to assume that it will fail. And failure is a must here for learn.
Ankit, shall we come to you with this next?
Yeah. So advice for the startup entrepreneur, that's a question, right? So I think as NASCOM, we are the pioneers in accelerating incubating startup, right? We had 10K startup mission. Right now, as we speak, we incubate around 1,000 plus deep tech and 500 plus AI startups, right? So learning from their journey and their sort of pain points. I think I think first I will completely agree with my panelist here. I think patient capital is a big issue, right? Again, I'll give an example, right? So a startup who is based in India versus US with the same team, same efficacies, almost similar product will get 10x funds there versus one here, right? The other side is the race there will be very fast versus race here will take so many cycles, right? I think that's the big issue. But the other things, so beyond that, I think the other thing what a startup I feel are missing is on few elements, right? First is 90% of our startups are application wrappers, right? Or wrapper on. So which is okay, right? Because the end, sort of financial ROI will come out of application of those AI into those fields, right? That's how it should be. But again, I think those also need to really up their game. I think the aspirations are low. Honestly, I think the aspiration of a startup in US, they would want to target $1 billion. Right? I met the startup founder yesterday, or I think last week. Yeah. Within 9 months, they have come to 100 million ARR. Right? Within 9 million, with a team of 30 people. This startup is based in US, right? Again, how can they do it? How can they expire something like that versus what we? And there will come the aspiration, the PMF, the right, angle where they would want to build something and take to the market. And this team, take the same example, is 29-member technical team, 1-member sales team, or I'll say founder of sales, whatever, right? So that's how it is. The PMF and the right entry point. That's that. The other angle is, since they are in India, right? I think we should leverage, again, the same point is that, how can they work for scale, right? If they can solve for scale, they can take it to globe, right? I think that's a next advice. The fourth is, I think is more, I think advice or more work with government initiatives. I think right in this age, a lot of options are available versus a decade back, right? So like Karnataka has Elevate program, right? They give phenomenal support to the startups here. Similarly, Mighty has. Similarly, ANF is announced, right? So be on an outlook of that and try to work around that, because that can really help you not sustain, but at least get to a certain point, right? I think these are the four things. And fifth is, when you're build with a safety layer at the base, right? Because many times we have seen startups, they build everything and then they have to grow to US or probably UK, right? Or Europe. Then they think they scratch their head on what a safety layer they have to add. So have the safety at the centerpiece when you're building, right? Yeah.
Yeah, I think those are great points. I will add maybe 3 things to what was already said. The first is, the statistic you mentioned of 90% of startups failing has nothing to do with AI. I mean, that's always the case, right? I think if it were not the case, then it would not require risk capital. I mean, you're not really talking about startups then, right? It's never a safe world. But 2 other points. I think I'll go back to something that Ankit said in answer to the first question, right? Which is, maybe I'm paraphrasing here, but I think you have to sort of think of what is your comparative advantage. And this is true with large companies or countries or whatever, right? So building yet another large language model may not be the smartest way to go about trying to build, because there are plenty of them out there. Each model seems to be at the top of the leaderboard for a few weeks, and the next one comes along. So in some sense, maybe a large model is a commodity. I mean, it's not, but I'm just saying, right? It is. But to make AI actually work for a real application, you need a lot of things around it, right? You need, I think in my talk this morning, I talked about retrieval as sort of one of the things you need. Make sure that you're pulling in the right stuff to put in the context. You need, evaluation. You need, ability to tune things for your particular task, right? So you might see a lot more leverage by making a dent on those than on the core large language model, as an example, right? The third thing that I would say, and I think this is universally true, is AI is a buzzword. Everyone has AI in their pitch and so on. Nothing wrong with that. Maybe that's a way to get some money in, but that's not the way to succeed ultimately. The only way you succeed is, are you solving a real problem? Are you solving a real problem for someone that either they're willing to pay you, or in the case of companies like Meta and Google and so on, they are willing to give you your attention, their attention, where they are giving an attention so you can monetize it other way, right? If you don't have something that's providing that kind of value, then you're not going to succeed. And AI is just a way to make it, to help with that process rather than an end in itself. Thank you.
Thank you. Yes, Dr. Jain.
Again, I agree with all the great points made by the panelists here. I would add a couple of points from energy and actually from capability point of view also. You should not think of the current status as sort of the status quo that will last for really long, which means that if you are thinking that, okay, I know that this is the capability of the model right now, I have some nice idea and I can make my model say 10% more energy efficient. Be very careful, because in next 3 months, a new model will come, which will then at the same sort of cost will give you much higher capability, or will bring the same capability of, let's say, the top end model at half the cost. So like the model capabilities and like the efficiency is improving rapidly, like, month on month. And on top of that, the chips, both like, say GPUs, TPUs, like all the accelerators, they are also rapidly improving. So if you are not talking about either a capability add or efficiency add of something like 10x, then you, like, at least in the standard sort of domains, the gains that you have will, like, wipe out very quickly, like within matter of months. So you have to make sure that either you are picking something where you have substantial leg up, or you are picking a domain which is niche enough, for which, let's say, the data or efficiency stuff will not be sort of, back propagated or back channeled into the model training for general large models, either by Google, OpenAI, Anthropic, etc. So you need to sort of make sure that you are looking at the trend rather than just the current, like the latest point. That's one thing. The other sort of aspect of it is that at the same time, like the AI, like the latest models, also become an ally in making your operations a lot more efficient, because now with all the coding model and knowledge work, etc., that these models can provide, you can operate with, like, 5 people, a startup that would have been able to do work of maybe 50 people or even 100 people. So one can sort of, start leveraging that, bringing efficiency in your operations in your system, and sort of, take it from there.
Over to you.
So my friends from the industry have already given a comprehensive answer for this question. So I would like to answer this question from the government point of view. So from the startups, what we generally expect is some kind of a unique solution. So the solution has to be adaptable, implementable across the various geographical areas and the socio-economic factors of the state, and also it has to be of reduced cost. For example, lot of startups, they have the same idea and they try to project it across different places, which may not be appreciated easily and quickly. For example, the other day I had given time for 2 startups to give presentation on their product, one in the morning and one in the evening. Both of them happened to be on data analytics, and I was just surprised to see that the content of the product was almost the same in both the products. So this may not be going well with the government sector, because our main aim is to have solutions which are quite unique, and they have to be futuristic, because as Mr. Jain has told, it has to be thinking about some 5 or 10 years down the line, given the increasing population, other socio-economic factors. The solutions that are going to be given by the startups, whether in AI or other technology, has to be futuristic and adaptable even 5 years or 10 years down the line. That is a very big expectation from the departments. So I would like to advise or suggest the startups to have a study of the actual requirement of the department in different context, and come up with the solutions that can be easily adopted and implemented.
Thank you. I think that unless our panelists have anything more to add, that brings our formal discussion itself to an end, but we do have about 10 minutes for questions and answers. So if any of you would like to raise your hand and...
I just want to add one point
yes,
here.
yeah.
Maybe this is a closed room workshop or the terminologies working group meeting. So I just wanted to add, I don't know who's taking notes, etc. The point which came from very very discussions. It's the idea is very simple. There is something called as, especially when I saw ambassadors or other people from other countries also. India being a nation which accepts all kind of culture, people, etc. India is one of the best nations to become a data sovereign nation. What it means today, I think Estonia and other countries, and Luxembourg, they have a agreement wherein one country's data is stored in another country, and they have a complete no restricted access. So India can be a country wherein it can host multiple countries' data. And data sovereignty is a concept which is coming up. It's like the embassy, data embassy. Like. So if anyone wants to think about those lines also, because that's the next big thing which can happen anywhere in the world, given the turmoil and the kind of things happening. So just to add.
Agree completely. Now, do we have any questions from the audience? Yes? Yeah. Okay. So if you can just introduce yourself very briefly and tell us who your question is addressed to.
Okay, I am Raghu. I work on disaster management. I have a question to Anbulan sir. Sir, Data Protection Act has come into being. Ministry of Home Affairs has notified the rules of Personal Data Protection Act. And now most of these free schemes, what you're giving in the government sector, a lot of data is available with you. So that rules, how you are able to implement, because in the last assembly session, a lot of misuse of fund, pre-scheme funds going to different accounts, all that happened, and I think so that discussion is already known on it's available on the site. So I just want to know what is the impact of this new rules which has been framed by MHA, and how it is going to impact your program locally in Karnataka, and as what he was trying to tell, sovereignty of data. Maybe Karnataka data should have, Tamil Nadu should have, and Tamil Nadu data should Karnataka. And in Andaman also we should have the whole India data should be there. If Andaman goes down, we should be able to retrieve it. So that is what is my question. You can just put a light on that, sir. Thank you.
Yeah. So the DPDP Act that has been introduced by the government of India has indeed imposed some restrictions on the state and other stakeholders in the system. But it has also empowered the governments in the state. For example, it has ensured the maximum protection for the data of each and every individual. So we are very much careful in handling the data of these individuals, that is our citizens, and we also ensure that each and every piece of data that is available with the government is being used responsibly. So as he has correctly mentioned, there are more than 50 departments in the government of Karnataka, and the data is very vast, and we have to be judging the utilization of the data properly. For example, recently we have done an exercise of the Graha Lakshmi scheme. Hopefully you all might be knowing what is Graha Lakshmi scheme. It is giving 2,000 rupees per woman in a household. So after this DPDP Act has come, this exercise was undertaken to identify those beneficiaries whose account numbers are not properly mapped in the existing system, or there is some flaw in the account numbers. So we were able to find out some account numbers of the beneficiaries who have already passed away few months back, and those account numbers which are being held outside the state. So these kind of data was available to us. Based on that, we were able to make some informed decisions. So this DPDP Act has also some provisions for sharing the data with other stakeholders. That includes the concept of a data sovereignty and all, because we will be sharing this data with multiple stakeholders, including Government of India, banks, and other entities. So it has indeed helped us rather than restricted us in our utilization and handling of the data.
Hello,
Okay,
Namaste. This is Venkat. Yeah, I'm a founder of a startup called Startup Sanatana. Sorry, I came really late. I was there somewhere else. In between, okay, I have lost my father. For that reason, I am there in this attire, ethical dress kind of thing. Otherwise, I'm a solutions architect. In fact, I'm a Microsoft MVP awardee also. I have attended the MVP Global Summit in Seattle kind of thing. Yeah, my question is, and I'm alumni also, IISc alumni. Yeah, my question is, okay, we are a serious technology startup. who wants to build the LLMs, especially on Indic languages, that too in particular, the Sanskrit and Vedas and things like that. And beautiful, session is happening. And recently also on Startup India 10th year thing, Narendra Modi ji, he spoke about like we will support any kind of vision, especially from the middle class and the from tier 2, tier 3 cities kind of thing. Definitely our government is going to support kind of thing. And my question is, since we want to build the sovereign, LLM based on the local languages, especially the Sanskrit or the Sanskrit and the Vedas in particular, how do we take it further with all your support kind of thing? And also we are coming out with some financial solutions also.
So who is your question addressed to, sir?
Anybody can.
Okay, would anyone like to take a shot at that? Anyone on the panel?
I can go ahead.
Ankit, yeah.
So thank you for bringing that question, right? I think one of the major, probably area where Indians have to work is the Indian knowledge systems, right? I think that's the area you're working. There's a lot of work happening in various institutes like IISc, IITs on that, right? I think happy to help you in any way, and NASCOM has helped some of the IKS projects across in last few years, right? So happy to help you in any way we can contribute to you, right? In terms of you're a startup, right? So you can come join our cohort. You get all the cohort facilities, all of that. So that's that. But beyond that, and anything specific, we can touch base in the sidelines and talk. Yeah.
Okay, if there are no more questions, and there don't seem to be, oh, okay, we do have two, all right. Two quick questions, three actually. The idea is to try and finish before 4:30, so let's keep it moving. Thank you.
Yeah, hi, I'm Sam. I'm a researcher in Chi Research Lab. So I just wanted to ask, as we know, the prices of GPUs are skyrocketing. It becomes increasingly difficult to train a competent LLM. And so in a research setting, we are fighting with, so we are trying to be in par with people who has a lot more resources. Not considering us, considering a general research group. So we can kind of interpret that the gap between the rich and the poor are, increasing in a span we can't even comprehend. So don't you guys think it would be like the research direction or the development direction should be shifted in that particular direction, and more emphasis has to be made in such a direction?
Yeah. So I think I'll say it reverse, right? The prices of GPUs has reduced. So H100, which was 2 years back, now has very minuscule cost, right? The efficiency and the output you're getting from GPU is increasing. Cost remains at the same, right? So probably that's one. But again, I think you're right. The accessibility of GPUs in the country is not more than 35,000 GPUs, right? A single company like Grok has 3 lakh GPUs. So we are talking about a huge differential, right? But that's what China did, right? China also was banned from getting any advanced GPUs. So researchers like you have to work in a way how you can find ways and means to bypass this restriction what we have as a country, right? What China did, right? China built their own grid computing. They built on their models which could work on low end GPUs, right? And then give the same results. So I think I will call upon on researchers like you and here. So you should work on research methodologies which can make this disadvantage an advantage, right? Now China is going and saying that we don't want your GPUs, right? That's how they are doing. So so it's there, but again, how we see it, it's an opportunity for you, I will say.
Yeah, that's a good answer, but it's like saying that so you should beat an F1 car with a Maruti Alto. So it's like so.
No, I'm not saying that. I'm not saying that. Yeah, I'm saying build an F1 car engine, right? You are a researcher, right? You have all the time in the world to sit and work on that. So build something which is not F1, but again better than F1 with the resources what you have. I'm not saying build a car which is like Alto, right? You build better than F1.
Good.
Yeah.
Sure. Thank you.
Yeah. Hi.
Okay, next question. Yeah.
The question is like, we talked about entrepreneurs, we talked about all those things. So but when we look into the resilient part, there are engineers who are sitting there in the academia for 4 years, learning same DSA and Algo from the day 1 of 2000 syllabus. They still read Balguruswami's learn with fun with C something. It's good. Its fundamentals is true required. But when you look into the resilient concept and the AI booming like this, the speed is so good. So what is your suggestion to yourself if you turn back 20 years old? And what would be your suggestion for us, people like us, to learn or explore?
I mean, this was a question which was asked to me by my son. Okay. So I told them very simple thing. I also learned the same thing. At least now, okay, this your syllabus are getting updated at least every 5 years. The universities, I don't know in IISc. Okay, maybe it's getting updated here every year. It should be. That's the way I assume. So I'll tell you the classic example. When we passed out, we had aptechs, NIITs, etc. At that time, ERP was the buzzword. Then learning Java was the buzzword. Whoever pass out will go somewhere and learn something like this. Okay, so the ecosystem will exist in one way or the other to support the demand. That has been always the case. Here also, an ecosystem is evolving. I'm answering your question and the previous question also. Okay. So when you were talking a lot of Sanskrit and other things in the morning, so at that time, I had a thought in my mind which came up. Okay, we have the Trimurti concepts, right? Brahma, Vishnu, Maheshwara, Srishti, Sthiti, Samhara. India, in the Y2K also, even today, why we are boasting about all the big companies here, we were only using the products for building applications. He made a comment, wrapper apps. That's the startups today. We have to get out of that thinking. As an IISc or student like you, we should say, why can't I build a GPU? What should I require? Put it on the working group as a concept. Let the mate look at it and say, yes, this is something concrete coming from this working group as a proposal. Let's do it. So that's your answer. The other thing is, so the ecosystem evolves over a period of time, right? So I told you NIITs and aptechs were there to teach us all what were. No, we did not know ERP systems that time. I'm being very open and frank. We just get into the companies and then, okay, this is the ERP, okay, okay. But by that time, we had a flavor of it because of those training institutes. When the startups came in, these are the people, NASCOM set up 1,000 startups or those kind of things across at that time, right? So evolves, ecosystem evolves always, okay? And second thing, as a good student, you have to seek information. That's how our system has traditionally been talking to, right? You go to a good guru and learn. So a good student should always find out where to find out the knowledge and learn. That's also another advice.
So let me, offer a personal anecdote, right? I think, first of all, I agree with you that, curriculum should be updated. But, I've never taken an AI course ever, right? Because when I got my bachelor's, master's, PhD degrees, it was in the 1990s. I guess it was one of these AI winters. AI was thought of all as just hype and so on. So never took a course, right? Obviously, that's a mistake in retrospect. I worry that today, mistakes of that kind are being done in the opposite direction. People just study some superficial AI. They don't know operating systems. They don't know networking. They don't know systems. And if you think about it, the deep learning revolution that happened in the past decade and a half is primarily a systems revolution, right? The basic algorithms were there, 30 years ago, 40 years ago. They could not run fast enough, right? With GPUs and being able to harness the power of these, the building systems. So my point is that as students today, it's important to actually learn fundamentals in a sort of wide range of topics so that you're equipped for the future, and because you don't know exactly what will be needed in the future.
Thanks for that. Okay, so in the interest of time, I will ask directly towards the theme of trustable and safety AI. So my question goes around, since the AI has been accelerated in the past few years, so we have this scope of guardrails, right? Especially when we are about to have the compliance of, say, in the medical field, HIPAA, and in terms of financial area, we have PCI and PAI compliance. And recently, our Indian government had introduced a DPTP related to have data within the borders of India. So having said these kind of compliance has been coming, has been there, and eventually in near future also, we might have new policies coming up. So when we have a agentic AI system, right now we have the multi-agent era, right? So to have an agentic AI system. So in this particular category, do you feel like, is there a particular regulated policy maker that can be integrated into our AI system? So which will make easier for the startups and government institutions, as well as the research institutes to not slow down on the innovation process. At the same time, they can quickly integrate this AI adoption with the guardrails, still compliant with all these policies. So your thoughts on that?
try this? A possible regulator for an agent for agentic AI, right? That's what you're suggesting.
So basically towards guardrails.
Guardrails, yeah.
See, the main purpose, if I have to answer your question from a government perspective, why many of the governments are not hosting anything on a private cloud, which is providing you the GPUs for doing these things, because of the same reason. And that is where this SLMs and other things came up. So wherever there is a critical data, okay, and national critical assets and certain things have been classified by many countries, okay, they are not exposing it to any of these public clouds or wherever this kind of cloud-based GPUs are being provided. It is separate one. India is also thinking of the same lines. Now, to your specific question, if you want to develop at your level for a hospital, I don't know. This question we should have asked for Dr. Shetty. How is he doing? Where is he keeping the data? But I'm saying in general, if it does not, data has also got multiple classifications, okay, as per the government regulations. So it's not that DPDP just says, one important thing I want to say in DPDP also, it only says about electronic data. It doesn't say about any other data. Nobody has asked this question till date, even after looking at DPDP, by the way, right? All other data, there's no need of privacy. So I'll give you a classic example. This is a personal case of mine. There was an accident in 2003. 10 years, driver was absconding. We tried all the best to find the person. Finally, I went to a police officer and told, sir, I need a help. 1 hour, he traced the person. So which means, what I'm trying to say is, whatever data you think is today yours, okay, I'm just saying from a sovereignty perspective of the role of government also here. Government is the sovereign authority to say, you are so-and-so, your name is so-and-so, your records are with them, etc. So as far as government is concerned, when your concern is primarily for privacy with the government, I don't think there is no problem. Because if they are protecting their data the way I told you, that's okay. But if in a private sector is using it, then these regulations has to be applied over a period of time. Again, it is evolving, right? I don't know if anyone in the room can answer what happens to the data once it goes inside your AI engine or a transformer. How is it stored? What is it happening? I have not got a concrete answer till date. Maybe Microsoft or Google review people can help me understand that. So I mean, I don't know. So that lies, okay? So any system for that matter, okay? It evolves over a period of time. Let's wait and watch. It'll happen. Okay? As long as we have a conscience which is deep enrolled in the people who are making policy, it will happen.
Thank you. And mostly when the coding agents are coming into picture.
We've really run out of time. Is this a very quick question?
Yeah.
I mean, then yes.
Yeah.
Just not
Online.
a statement, just a question.
Online.
Yeah,
so,
one line.
with this AI evolution and adaptation, so current era, is it kind of like a doom for SaaS-based companies and a boom for deep tech companies?
Dr. Jain, do you want to try that?
I think like that's true. That definitely like deep tech is getting its due. But at the same time, it's also a very good time to build a SaaS company because you can sort of now using AI models, you can sort of automate a lot of work. You can bring new abstractions on how people can use your systems, which means that you can build like say the SaaS companies of past in few months with much fewer power. And you can design new interfaces, new sort of abstraction. So I feel like it's not complete doom. There is a fair bit of opportunity, and I think a lot of people are building some interesting sort of solutions here. So.
All right, thank you. I think that brings this particular session to an end. So thank you very much for being a very engaged audience, and a big round of applause for our panelists, please, for making the time to be here. And thank you very much once again.
I request our moderator to felicitate our panelists. Shri T. Bhubalan. Mr. Prasad Onikrishnan. Mr. Prateek Jain. Mr. Venkat Padmanabhan. Mr. Ankit Bose. I request Professor Chiranjeev to felicitate our moderator. Thank you to all. As the summit is coming to an end, I invite Mr. Abhishek Agarwal to address the gathering.
So as we conclude this session, I would like to thank all our speakers and participants for a very focused and constructive discussion. Today's exchanges clearly highlighted that the future of AI will not depend only on innovation, but on how efficiently and responsibly AI systems are designed and scaled. As adoption accelerates, issues of energy usage, infrastructure stress, and system reliability are no longer secondary concerns. They are central to long-term process. A key takeaway from today is that efficiency must be built on into AI systems from the outset. This is not just a technical choice, but a strategic one with implications for sustainability, accessibility, and resilience. We also heard the importance of designing AI that can operate reliably under the real-world constraints and remain robust in the face of disruption. Equally strong message was on collaboration. No single country or institution can address these challenges alone. Shared learning and international cooperation will be critical in shaping practical and adaptable pathways for resilient and resource-conscious AI. As we move towards the India AI Impact Summit 2026, the insights of this working group will directly inform our work on guiding principles and practical pathways for efficient AI. These conversations will help ensure that global ambition is grounded in real-world realities. I warmly invite all of you to continue this engagement and join us at the India AI Impact Summit 2026, where these conversations will come together at a global level. Thank you once again for your time, your insights, and your continued engagement. We look forward to carrying this work together. Thank you.
I invite Professor Chiranjeev to come on stage.
What a shock. So, good evening to all of you. I know it's the last session. Thanks for staying back. But if you had enjoyed the program, then I would request you to thank all the people who has this orange and the yellow tags, especially the yellow tags. You know, this program was brought together by Government of Karnataka, MIT, and IISc. Now, if you have heard these three terms together,
the first impression is, oh, government of Karnataka, mighty, IISc, bureaucratic organization, how can they work together? The first thing. So yes, it was a challenge, but these amazing people whose names I'm going to read out, and I would like you, to all of you, if they are here, I would like them to stand up. If not, please applaud them. These are the people whom have troubled with more than 5 WhatsApp messages. Okay, so Government of Karnataka, Madam Pramodita Hegde, please. Mighty Madam Shikha Dahiya. She's the director. She's unfortunately couldn't come here today. But of course, the soldiers on the ground from Mighty, the NEGT team and the IndiaAI team are there. They did a fantastic job. They helped in many of these things, even slides to stage presentations. So my point of contact, Miss Bhabya Singh, and of course, there are a big group there. Bhabya, I think, is not taking my phone calls anymore, I guess. And now comes IISc. Of course, we have IISc administrative support, Professor Rajesh Sundaresan, Professor Anil Kumar. Behind the scenes, they have enabled many things. So a great round of applause for them. As I said, I messaged them, right? That is the baseline. But this heavy lifting, see, for example, there are many organizations inside IISc who has contributed a lot. For example, FSID. So Mr. Sandeep is here, orange badge. Mr. Om Prakash, I'm not sure he's here anymore. Maybe I've left. But most of all, the 2 young ladies, one is Madhumita and another is our Sara. Sara, can you come here, please? These ladies have, I do not know, like they may not have slept for a few nights. From KISC, Madam Sudha and Madam Gitanjali. Madam Gitanjali here, can you stand up, please? And of course, from Art Park, Madam Akshata. We heard a lot about Tanu, Raj Acharya. So a big round of applause for Raj. Can you stand up, please? Okay. And last of all, so some student volunteers, they also played a great role. So Adit, Dhruva, can you stand up, please? Adit, Dhruva, Pranav, Sam, Ayon, and among the Parivasha. Are you there? So these are the people who made this possible. I had a 1-hour-long speech thanks to ChatGPT, but unfortunately, there's no time for that. Next time, I'll invite you again. Hopefully, you'll do this event again, no? So with that, I would, warmly thank you again for making the time to come here and engage in this contribution and contributing your thoughts. So thank you again. Wish you all the best.
There's tea arranged in the 3rd floor for everybody. Please do join.
No, that is, it is good, sir. Book it is good. But the education actually, there is one thing,